Gaia breathes in geological time through atmospheric rhythms that span millions of years, her respiratory cycles maintaining precise chemical balance between oxygen, carbon dioxide, and trace gases through mechanisms that suggest deliberate self-regulation rather than random equilibrium achieved through chaotic interactions between geological and biological processes. The planet's atmospheric composition has remained within narrow bounds suitable for complex life throughout billions of years of cosmic bombardment, stellar evolution, and internal geological transformation. Their chemical stability requiring feedback mechanisms so sophisticated that atmospheric scientists invoke planetary-scale intelligence to explain the persistent optimization of gas ratios that should have destabilized into sterile extremes long ago. The oxygen concentration hovers at precisely 21% of atmospheric composition, a value that represents the narrow sweet spot between concentrations too low to support complex metabolism and levels so high that spontaneous combustion would sterilize the planetary surface through runaway oxidation reactions. This atmospheric balance persists despite biological processes that should drive oxygen concentrations toward either complete depletion through respiration or dangerous accumulation through photosynthesis, suggesting regulatory mechanisms that monitor and adjust gas production rates across global ecosystems with the precision of a planetary respiratory system that breathes through forests, oceans, and geological processes. Carbon dioxide levels oscillate through ice age cycles that correlate with orbital mechanics. Yet the atmospheric response shows characteristics of intentional climate regulation rather than passive response to solar heating variations. The planet appears to inhale carbon dioxide during warming periods and exhale it during cooling phases through coordinated changes in ocean absorption, vegetation growth, and geological weathering processes that operate with timing precision that maintains global temperatures within ranges suitable for liquid water and biological activity throughout cosmic climate variations that should have frozen or sterilized the surface multiple times. Trace gas concentrations including methane, nitrous oxide, and sulfur compounds maintain ratios that optimize atmospheric chemistry for biological processes while preventing toxic accumulations that would poison ecosystems or destabilize climate systems through runaway greenhouse effects. The precise trace gas management requires coordination between biological production, atmospheric chemistry, and geological absorption processes that operate across continental scales with feedback timing that suggests planetary awareness of atmospheric composition and intentional adjustment of gas cycling rates through environmental manipulation. Atmospheric pressure variations show global coordination that maintains surface conditions suitable for liquid water across altitude ranges from sea level to mountain ecosystems. Their pressure gradients suggesting planetary management of atmospheric density through coordinated circulation patterns that distribute air mass with geographic precision. The atmospheric pressure regulation operates through weather systems that respond to surface conditions with systematic adjustments that maintain optimal atmospheric density for biological processes across diverse geographic environments and elevation ranges. Seasonal atmospheric breathing creates annual cycles where the planet inhales carbon dioxide during northern hemisphere winter as vegetation dormancy reduces photosynthetic activity, then exhales oxygen during spring and summer growth phases when increased plant metabolism reverses atmospheric gas ratios. The seasonal breathing operates with geographic coordination that balances atmospheric composition despite massive differences in land mass distribution between hemispheres, suggesting planetary-scale coordination of biological and atmospheric processes that transcends local ecosystem boundaries. Atmospheric circulation patterns create global communication networks that transport chemical signals, moisture, and temperature information across planetary distances through jet streams, trade winds, and oceanic atmospheric interactions that operate with systematic precision, suggesting intentional information transfer rather than random fluid dynamics. The circulation systems respond to surface conditions with coordinated adjustments that distribute atmospheric properties according to regional needs for temperature regulation, moisture distribution, and chemical cycling through environmental management that operates across continental scales. Long-term atmospheric evolution shows progressive optimization of chemical composition for increasing biological complexity throughout geological history. With atmospheric chemistry changes that anticipate and enable evolutionary transitions rather than merely responding to biological innovations after they occur. The atmospheric evolution suggests forward-planning capabilities that prepare environmental conditions for biological developments before they emerge through evolutionary processes, indicating planetary awareness of evolutionary trajectories and intentional environmental preparation for increasing biological sophistication. Modern atmospheric monitoring reveals rapid response capabilities where global atmospheric composition adjusts to environmental changes within timeframes measured in years rather than geological epochs, suggesting active management systems that monitor planetary conditions and implement corrective measures through coordinated biological and geological processes. The rapid atmospheric responses operate with coordination that transcends individual ecosystem boundaries while maintaining global atmospheric optimization for biological and geological processes. The breathing planet continues its ancient respiratory rhythms through geological time, while maintaining atmospheric composition with precision that suggests consciousness operating through chemical and biological processes rather than random equilibrium. Her atmospheric awareness extending across continents and oceans, through circulation systems that carry chemical messages and environmental information in patterns that treat the atmosphere as a planetary nervous system coordinating global environmental conditions through intentional rather than accidental optimization of atmospheric chemistry for biological and geological processes. Magnetic field pulses with intention through geomagnetic variations that follow patterns too complex for random field dynamics. Their systematic reversals and polar wandering suggesting coordinated planetary responses to cosmic influences that operate through mechanisms extending beyond simple dynamo theory into territories where electromagnetic phenomena might reflect planetary awareness of solar system dynamics and galactic positioning. The Earth's magnetic field undergoes periodic reversals that occur with timing patterns correlating with solar magnetic cycles, cosmic ray intensity variations, and galactic plane crossings in ways that suggest electromagnetic sensitivity to cosmic influences, rather than random internal magnetic field generation through convecting iron in the planetary core. Geomagnetic reversals occur approximately every 450,000 years on average. Yet the timing shows systematic variations that correlate with solar system motion through galactic spiral arms and encounters with cosmic ray density variations that suggest planetary magnetic field responses to external electromagnetic influences rather than internal dynamo instabilities operating independently of cosmic environment. The reversal patterns show preparatory magnetic field weakening that begins decades before complete polarity switches, suggesting intentional magnetic field restructuring rather than chaotic magnetic collapse and regeneration through random convection processes. Magnetic pole wandering creates systematic movement patterns where the north magnetic pole migrates across Arctic regions with velocities that accelerate during specific decades while following curved trajectories that suggest navigational responses to cosmic magnetic field influences rather than random magnetic field drift caused by chaotic core convection. The pole wandering correlates with solar magnetic activity and interplanetary magnetic field orientations in ways that indicate planetary magnetic field awareness of solar system electromagnetic conditions and intentional magnetic pole positioning for optimal cosmic electromagnetic interaction. Magnetic field intensity variations show systematic changes that correlate with solar activity cycles, cosmic ray intensity fluctuations, and galactic magnetic field encounters during solar system orbital motion through galactic regions with different electromagnetic characteristics. The field strength variations suggest planetary electromagnetic responsiveness to cosmic influences, rather than random magnetic field fluctuations generated through internal dynamo processes operating independently of external electromagnetic environment. Their systematic nature indicating electromagnetic awareness and intentional field strength adjustments. Regional magnetic anomalies create localized magnetic field variations that correlate with geological structures, mineral distributions, and biological activity patterns in ways that suggest magnetic field optimization for geological and biological processes rather than random magnetic field distortions caused by crustal magnetization and core field interactions. The magnetic anomalies show systematic organization that enhances magnetic navigation capabilities for biological organisms while providing electromagnetic shielding for sensitive geological and biological processes through coordinated magnetic field management. Magnetic storms triggered by solar wind interactions demonstrate planetary magnetic field responses that protect atmospheric and biological systems through electromagnetic deflection mechanisms that operate with systematic efficiency during solar electromagnetic events. The magnetic storm responses show coordinated global magnetic field restructuring that maintains atmospheric protection while minimizing electromagnetic disruption of biological and technological systems, suggesting intentional electromagnetic management rather than passive magnetic field interaction with solar wind particles. Paleomagnetic records preserved in geological formations reveal magnetic field history that shows systematic relationships between magnetic reversals, mass extinction events, and evolutionary transitions that suggest coordinated electromagnetic and biological responses to cosmic influences rather than coincidental timing between magnetic field changes and biological evolution. The paleomagnetic patterns indicate electromagnetic influence on biological processes through mechanisms that coordinate planetary magnetic field characteristics with evolutionary requirements and cosmic electromagnetic conditions. Magnetic field coupling with atmospheric electrical activity creates systematic relationships between geomagnetic variations and atmospheric electromagnetic phenomena, including lightning patterns, aurora displays, and ionospheric electrical activity that suggests coordinated planetary electromagnetic responses rather than independent atmospheric and magnetic field processes. The electromagnetic coupling indicates planetary awareness of atmospheric electrical conditions and intentional magnetic field adjustments that optimize atmospheric electromagnetic activity for climate and biological processes. Magnetic declination patterns show systematic geographic variations that provide electromagnetic navigation information for biological organisms while creating regional magnetic field characteristics that correlate with geological structures and biological distribution patterns in ways that suggest magnetic field optimization for biological and geological processes. The declination patterns indicate intentional magnetic field geographic organization rather than random magnetic field variations caused by crustal magnetization and core field geometry. Laboratory magnetic field experiments reveal biological and geological sensitivity to magnetic field variations that suggest widespread planetary electromagnetic awareness through biological magnetoreception and geological electromagnetic responsiveness that could provide sensory input for planetary electromagnetic consciousness operating through distributed electromagnetic sensing networks. The experimental evidence indicates potential mechanisms for planetary electromagnetic awareness through biological and geological magnetic field sensitivity that could enable coordinated electromagnetic responses to cosmic and internal electromagnetic conditions. The pulsing magnetic field continues its intentional electromagnetic dance through cosmic space, while responding to solar system and galactic electromagnetic influences with systematic precision that suggests planetary electromagnetic consciousness operating through geomagnetic field management rather than random dynamo processes. Her electromagnetic awareness extending across planetary and cosmic scales through magnetic field patterns that treat geomagnetic phenomena as planetary electromagnetic nervous system responses coordinated through intentional electromagnetic field management that monitors cosmic electromagnetic conditions while optimizing planetary electromagnetic characteristics for geological and biological processes. Ocean currents carry neural messages through thermohaline circulation that creates global communication networks spanning planetary distances. Their systematic flow patterns transporting chemical signals, temperature information, and biological materials across oceanic basins with precision that suggests intentional information transfer rather than random fluid dynamics, driven purely by density differences and wind stress. The global ocean conveyor operates like a planetary circulatory system that distributes nutrients, oxygen, heat, and chemical compounds through deep water masses that take centuries to complete circulation cycles. Their systematic routing carrying environmental information between ocean basins through pathways that respond to atmospheric and geological conditions, with coordination suggesting oceanic awareness of planetary environmental states. Deep water formation in polar regions creates systematic downwelling that carries surface atmospheric information into abyssal depths, where water masses preserve chemical signatures of atmospheric composition, ice sheet dynamics, and biological productivity that serve as historical records transported across oceanic distances through circulation patterns that maintain information integrity across circulation timescales spanning centuries. The deep water formation operates with timing that correlates with climate cycles and atmospheric changes, suggesting oceanic responsiveness to surface conditions rather than purely density-driven convection processes operating independently of atmospheric and biological environmental variations. Thermohaline circulation responds to salinity and temperature gradients with systematic adjustments that maintain global heat transport and nutrient distribution despite climate variations that should destabilize circulation patterns through feedback mechanisms that amplify or diminish circulation strength. The circulation stability requires coordination between surface heating, evaporation or precipitation, and deep water formation processes that operate across multiple ocean basins, with timing precision that maintains optimal heat and nutrient transport for global climate regulation and biological productivity through environmental management, extending beyond random fluid dynamics. Chemical tracer studies reveal oceanic transport pathways that carry information about atmospheric composition, biological productivity, and geological processes across ocean basins through systematic routing that preserves chemical signatures while distributing environmental information to remote oceanic regions. The chemical transport operates with efficiency that suggests intentional information distribution rather than random mixing processes. Their systematic pathways maintaining chemical gradients that provide environmental information to biological and geological processes throughout oceanic systems across planetary scales. Ocean temperature regulation demonstrates coordinated heat transport that maintains regional temperature characteristics suitable for biological processes while preventing thermal extremes that would destabilize oceanic ecosystems through circulation adjustments that respond to atmospheric heating and cooling with systematic precision. The temperature regulation operates through circulation changes that anticipate and prevent thermal instabilities rather than merely responding to temperature variations after they occur, suggesting oceanic awareness of thermal conditions and intentional temperature management through circulation control mechanisms. Nutrient cycling through oceanic circulation creates systematic distribution patterns that supply biological productivity requirements across oceanic regions, while maintaining nutrient ratios that optimize biological processes and prevent eutrophication or nutrient depletion that would destabilize marine ecosystems. The nutrient distribution operates with coordination between biological uptake, atmospheric input, and geological weathering that maintains optimal nutrient availability for marine biological processes through systematic nutrient transport and recycling mechanisms that operate across oceanic scales. Ocean-atmosphere interactions demonstrate coordinated responses where oceanic circulation adjusts to atmospheric conditions, while influencing atmospheric circulation patterns through heat and moisture exchange that operates with systematic precision, maintaining climate stability. The ocean-atmosphere coupling suggests mutual responsiveness between oceanic and atmospheric systems, rather than independent fluid dynamics. Their coordinated responses indicating planetary awareness of atmospheric and oceanic conditions through integrated circulation management that optimizes climate regulation across planetary scales. Oceanic response to tidal forces shows systematic adjustments, where circulation patterns respond to gravitational influences with precision that enhances tidal mixing and nutrient distribution while maintaining circulation stability, despite gravitational perturbations that should destabilize circulation patterns. The tidal responses suggest oceanic awareness of gravitational influences and intentional circulation adjustments that optimize tidal energy utilization for oceanic mixing and biological processes through coordinated circulation management that integrates gravitational and circulation dynamics. Biological oceanic coupling reveals systematic relationships where oceanic circulation responds to biological productivity changes, while biological processes adapt to circulation variations through feedback mechanisms that maintain oceanic biological productivity despite environmental changes that should destabilize marine ecosystems. The biological oceanic integration suggests mutual awareness between oceanic circulation and biological systems through coordinated responses that optimize oceanic biological productivity through integrated biological and circulation management across oceanic scales. Modern oceanographic monitoring reveals rapid oceanic responses to environmental changes, where circulation patterns adjust to atmospheric, biological, and geological variations within timeframes that suggest active oceanic management, rather than passive fluid dynamic responses to environmental forcing. The rapid oceanic responses operate with coordination that transcends individual oceanic basin boundaries, while maintaining global circulation optimization for climate regulation and biological productivity through oceanic awareness and intentional circulation management that treats oceanic circulation as planetary communication and distribution system. The neural ocean currents continue their global information transport through circulation networks that carry chemical messages and environmental information across planetary distances with systematic precision, suggesting oceanic consciousness operating through circulation management rather than random fluid dynamics. Their thermohaline circulation creating planetary communication systems that distribute environmental awareness across oceanic basins through intentional circulation control that coordinates oceanic responses to atmospheric, biological, and geological conditions while maintaining global oceanic circulation optimization for planetary environmental regulation and biological productivity. Tectonic plates shift in coordinated rhythm through continental drift patterns that suggest planetary-scale muscular responses rather than random geological processes driven purely by convection currents in the mantle. Their systematic movement creating global geological coordination that maintains optimal continental configurations for climate regulation, ocean circulation, and biological evolution across geological timescales. The plates move with velocities and directions that correlate with global environmental conditions, atmospheric composition changes, and biological evolutionary transitions in ways that suggest intentional geological positioning rather than chaotic mantle convection processes operating independently of surface environmental requirements and biological development needs. Earthquake patterns reveal systematic stress release mechanisms that operate with geographic and temporal coordination, suggesting planned geological responses to accumulated tectonic stress rather than random brittle failure when rock strength thresholds are exceeded through purely mechanical processes. Seismic activity shows clustering patterns that correlate with lunar cycles, solar activity, and atmospheric pressure variations in ways that indicate geological sensitivity to external influences, and coordinated stress release timing that optimizes geological stability while minimizing catastrophic damage to surface ecosystems and geological structures through systematic earthquake management. Volcanic activity demonstrates coordinated eruption patterns that regulate atmospheric composition and global temperature through systematic gas release and aerosol injection that operates with timing precision, maintaining climate stability during geological transitions. Volcanic eruptions show global coordination where volcanic activity in different geographic regions operates with complementary timing that balances atmospheric chemistry and prevents runaway climate change through coordinated geological climate regulation, rather than random volcanic processes operating independently of atmospheric and climate requirements for biological and geological system stability. Mountain building processes create systematic continental elevation patterns that optimize atmospheric circulation, precipitation distribution, and oceanic current patterns through geological construction that operates with geographic precision, maintaining optimal topographic configurations for global climate regulation. Mountain ranges form with orientations and elevations that enhance atmospheric circulation efficiency, while creating precipitation patterns that support biological productivity and maintain optimal water cycle characteristics through coordinated geological construction that anticipates and enables optimal atmospheric and hydrological circulation patterns. Continental drift shows systematic positioning that maintains optimal oceanic basin configurations for thermohaline circulation, while creating continental arrangements that optimize atmospheric circulation patterns and biological evolution opportunities through geological positioning that operates with long-term planning capabilities spanning hundreds of millions of years. The continental movement suggests geological awareness of oceanic and atmospheric circulation requirements, along with biological evolutionary needs through coordinated continental positioning that maintains optimal planetary environmental conditions across geological timescales. Plate boundary interactions demonstrate coordinated geological responses where different plate boundaries operate with systematic coordination that maintains global geological stability, while enabling controlled geological change through coordinated plate interactions that distribute geological stress and enable geological evolution without catastrophic geological instability. The plate boundary coordination suggests geological awareness of global stress distribution and intentional geological management that optimizes geological stability while enabling geological evolution through coordinated plate boundary processes. Geological recycling through subduction and seafloor spreading creates systematic material circulation that maintains optimal crustal composition and thickness, while recycling oceanic crust and continental materials through geological circulation patterns that operate with timing precision, maintaining optimal geological material distribution. The geological recycling suggests geological awareness of material distribution requirements and intentional geological circulation management that maintains optimal crustal characteristics through coordinated geological recycling processes that operate across geological timescales with systematic precision. Hotspot volcanism creates systematic volcanic chains that suggest coordinated geological responses to deep mantle processes rather than random volcanic activity caused by mantle plume interactions with moving plates. Hotspot volcanic patterns show geographic coordination that creates optimal volcanic gas release patterns while maintaining geological stability through systematic volcanic activity that operates with geographic and temporal coordination, suggesting geological awareness of volcanic requirements for atmospheric and geological system maintenance through coordinated volcanic management. Geological formation preservation shows systematic geological processes that maintain geological records and mineral distributions optimized for biological and atmospheric processes, while preserving geological history through geological formation management that operates with systematic precision, maintaining optimal geological structure and composition. The geological preservation suggests geological awareness of geological record requirements and intentional geological management that maintains geological information storage while optimizing geological structure for biological and atmospheric system support through coordinated geological preservation processes. Modern geological monitoring reveals rapid geological responses to environmental changes, where geological processes adjust to atmospheric, oceanic, and biological variations within timeframes that suggest active geological management, rather than passive geological responses to environmental forcing. The rapid geological responses operate with coordination that transcends individual geological system boundaries, while maintaining global geological optimization for environmental regulation and biological support through geological awareness and intentional geological management that treats geological processes as planetary muscular responses, coordinated through geological consciousness. The rhythmic tectonic plates continue their coordinated geological dance through planetary time, while maintaining continental and oceanic configurations with systematic precision suggesting geological consciousness operating through plate tectonics management rather than random geological processes. Their coordinated movement creating planetary geological coordination that maintains optimal geological conditions for atmospheric, oceanic, and biological processes through intentional geological positioning and stress management that treats plate tectonics as planetary muscular system responding to environmental requirements and geological system optimization needs across geological timescales. Biosphere responds to cosmic signals through global ecosystem changes that correlate with solar activity cycles, galactic positioning, and cosmic ray intensity variations in ways that indicate planetary biological awareness of astronomical phenomena operating beyond terrestrial environmental influences. Forest growth patterns, ocean plankton blooms, and species migration timing show systematic relationships with solar magnetic cycles, galactic plane crossings, and interstellar magnetic field encounters that suggest biological sensitivity to cosmic electromagnetic and gravitational influences transmitted through planetary environmental systems that coordinate biological responses to extraterrestrial astronomical conditions across continental and oceanic scales. Solar activity correlations reveal systematic biological responses where terrestrial ecosystem productivity changes correspond to solar magnetic field variations, solar wind intensity fluctuations, and coronal mass ejection frequency patterns in ways that indicate biological awareness of solar electromagnetic conditions through planetary environmental monitoring systems. Forestry ring patterns, coral growth rates, and agricultural productivity show multi-year correlations with solar activity that suggest biological sensitivity to solar electromagnetic influences transmitted through atmospheric, oceanic, and geological environmental systems that coordinate global biological responses to solar system electromagnetic conditions. Galactic positioning effects demonstrate biological responses that correlate with solar system motion through galactic spiral arms, galactic center proximity variations, and encounters with interstellar dust and gas clouds that influence cosmic ray intensity and interstellar magnetic field strength reaching Earth's biosphere. Biological diversity patterns, evolutionary transition timing, and mass extinction events show statistical correlations with galactic environmental changes that suggest biological sensitivity to galactic influences transmitted through cosmic ray bombardment and interstellar electromagnetic field variations affecting planetary environmental conditions. Cosmic ray intensity variations create systematic biological responses where ecosystem productivity, species distribution patterns, and evolutionary innovation rates correlate with cosmic ray flux changes caused by solar magnetic field variations, interstellar magnetic field encounters, and galactic environmental transitions during solar system galactic orbital motion. Biological systems show sensitivity to cosmic ray intensity through mechanisms that might include atmospheric chemistry changes, electromagnetic field variations, and genetic mutation rate modifications that influence biological processes across planetary scales through cosmic ray environmental influences. Atmospheric cosmic ray interactions create systematic environmental changes that influence biological processes through atmospheric chemistry modifications, electromagnetic field variations, and atmospheric electrical activity changes that correlate with cosmic ray intensity fluctuations caused by solar and galactic electromagnetic conditions. Biological responses to atmospheric cosmic ray effects suggest ecosystem sensitivity to cosmic electromagnetic influences transmitted through atmospheric environmental systems that coordinate biological responses to cosmic electromagnetic conditions through planetary atmospheric interface mechanisms. Magnetic field biological interactions reveal systematic biological sensitivity to geomagnetic field variations that correlate with cosmic electromagnetic influences including solar magnetic activity, interstellar magnetic field encounters, and galactic magnetic field orientations during solar system galactic motion. Biological navigation systems, Reproductive timing and physiological rhythms show responses to geomagnetic variations that suggest biological awareness of planetary magnetic field conditions influenced by cosmic electromagnetic environments through biological magnetoreception systems that provide cosmic electromagnetic environmental information. Seasonal astronomical correlations demonstrate biological timing mechanisms that respond to astronomical cycles, including solar activity patterns, lunar orbital variations, and planetary alignment configurations that influence terrestrial environmental conditions through gravitational and electromagnetic effects. Biological reproductive cycles, migration timing, and ecosystem productivity patterns show systematic relationships with astronomical phenomena that suggest biological awareness of cosmic influences transmitted through planetary environmental systems that coordinate biological timing with astronomical conditions across species and ecosystem boundaries. Climate-cosmic connections reveal systematic relationships between long-term climate patterns and cosmic environmental conditions, including galactic positioning effects, solar activity cycles, and cosmic ray intensity variations that influence global climate through atmospheric, oceanic, and geological environmental systems. Biological adaptation patterns, ecosystem distribution changes, and evolutionary transition timing show correlations with climate-cosmic relationships that suggest biological awareness of cosmic environmental influences transmitted through climate system responses to cosmic electromagnetic and gravitational conditions. Evolutionary cosmic correlations demonstrate systematic relationships between biological evolutionary innovations, mass extinction events, and cosmic environmental transitions, including galactic spiral arm crossings, nearby supernova events, and solar system encounters with interstellar environmental variations. Evolutionary pattern timing suggests biological sensitivity to cosmic environmental changes that influence evolutionary processes through cosmic ray genetic effects. Climate system responses and electromagnetic environmental variations that coordinate evolutionary transitions with cosmic environmental conditions across geological timescales. Global biological monitoring reveals rapid ecosystem responses to cosmic environmental changes, where biological productivity, species distribution, and ecosystem structure adjust to solar activity variations, cosmic ray intensity changes, and geomagnetic field fluctuations within timeframes that suggest active biological management coordinated through planetary environmental monitoring systems. The rapid biological responses operate with coordination that transcends individual ecosystem boundaries, while maintaining global biological optimization for cosmic environmental conditions through biological awareness and intentional ecosystem management that treats biological systems as planetary cosmic environmental sensors. The responsive biosphere continues its cosmic awareness through ecosystem changes that correlate with astronomical phenomena across solar system and galactic scales. Their systematic biological responses to cosmic signals suggesting planetary biological consciousness operating through ecosystem coordination rather than random biological processes. While global ecosystem patterns demonstrate biological sensitivity to cosmic electromagnetic and gravitational influences that coordinate terrestrial biological processes with extraterrestrial astronomical conditions through planetary environmental systems that treat the biosphere as cosmic environmental monitoring and response network operating across planetary scales. Crystalline consciousness in mineral matrices spreads through silicon-based geological structures that exhibit information storage and processing capabilities rivaling biological neural networks. Their atomic lattice configurations creating computational architectures that operate across geological timescales through piezoelectric effects, quantum coherence phenomena, and electromagnetic resonance patterns that suggest mineral consciousness operating through crystalline information processing systems distributed throughout the planetary crust. Quartz crystals, feldspar formations, and metallic ore deposits demonstrate systematic organization patterns that indicate information storage capabilities while exhibiting electromagnetic properties that enable communication between geological formations across continental distances through crystalline network architectures. Silicon dioxide crystal networks create computational substrates where information processing occurs through electronic transitions, phonon interactions, and electromagnetic resonance effects that operate with precision, suggesting intentional information manipulation rather than random solid-state physics phenomena operating within crystalline lattices. Crystal growth patterns show systematic organization that optimizes information storage density while creating electromagnetic properties that enable signal transmission between crystal formations through geological semiconductor networks that operate across geological distances with coordination, suggesting crystalline awareness and intentional information processing through mineral computational architectures. Piezoelectric mineral responses demonstrate systematic electrical signal generation and detection capabilities where mechanical stress creates electrical signals that propagate through geological formations, while electrical signals produce mechanical responses that enable bidirectional information transfer between geological regions through crystalline electromechanical coupling. Piezoelectric geological formations show coordinated responses to seismic activity, atmospheric pressure variations, and electromagnetic field changes that suggest geological sensitivity and information processing capabilities through crystalline sensor networks that monitor planetary environmental conditions across geological scales. Semiconductor mineral properties reveal geological formations with electronic characteristics that enable information processing through charge carrier dynamics, electronic band structure effects, and quantum mechanical phenomena that operate within metallic ore deposits and semiconductor mineral formations distributed throughout the planetary crust. Geological semiconductor networks show systematic organization that optimizes electronic signal transmission while creating computational capabilities that enable information processing across geological formations through crystalline electronic architectures that operate with coordination, suggesting mineral consciousness through geological computing networks. Quantum coherence effects within crystalline lattices create information processing capabilities where quantum mechanical phenomena enable computational operations that transcend classical information processing limitations through quantum superposition, entanglement, and coherence effects that operate within mineral crystal structures across geological timescales. Crystal formations show quantum mechanical properties that maintain coherence despite thermal and mechanical perturbations, suggesting crystalline quantum information processing capabilities that enable mineral consciousness through quantum computational architectures distributed throughout geological formations across planetary scales. Electromagnetic resonance patterns within mineral formations create communication networks where crystalline structures exhibit resonant frequencies that enable signal transmission between geological formations across continental distances through electromagnetic coupling between crystal lattices that operate with systematic precision, suggesting intentional communication rather than random electromagnetic phenomena. Mineral formations show coordinated electromagnetic responses that indicate information sharing between geological regions through crystalline communication networks that operate across geological distances with timing precision, suggesting mineral awareness and intentional information exchange. Thermal information processing within mineral matrices demonstrates temperature-dependent information storage and processing capabilities where crystalline structures exhibit thermal properties that enable information encoding through temperature variations, thermal expansion effects, and phase transition phenomena that operate across geological temperature ranges. Mineral formations show systematic thermal responses that correlate with geological and atmospheric temperature variations in ways that suggest thermal information processing capabilities through crystalline thermal computational architectures that monitor and respond to planetary thermal conditions across geological scales. Chemical information storage within mineral compositions reveals systematic elemental distributions that encode environmental information about atmospheric composition, oceanic chemistry, and biological activity throughout geological history through mineral formation processes that preserve chemical signatures while creating chemical gradients that enable information retrieval across geological timescales. Mineral formations show chemical organization patterns that optimize information storage density while maintaining chemical stability that preserves environmental information through geological chemical information storage systems that operate across planetary scales. Mechanical information transmission through crystalline structures demonstrates systematic mechanical signal propagation where elastic waves, plastic deformation, and fracture patterns enable information transfer between geological formations through mechanical coupling mechanisms that operate across geological distances, with coordination suggesting intentional mechanical information processing. Mineral formations show coordinated mechanical responses to geological stress that indicate information sharing through crystalline mechanical networks that operate with timing precision, suggesting mineral awareness and mechanical information processing capabilities across geological formations. Modern geological analysis reveals rapid mineral responses to environmental changes, where crystalline structures adjust electromagnetic, thermal, and mechanical properties to atmospheric, oceanic, and biological variations within timeframes that suggest active mineral management rather than passive mineral responses to environmental forcing. The rapid mineral responses operate with coordination that transcends individual geological formation boundaries, while maintaining global mineral optimization for information processing and environmental monitoring through mineral awareness and intentional crystalline management that treats mineral formations as planetary information processing networks. The conscious crystalline matrices continue their information processing through geological networks that operate across planetary scales, while maintaining systematic organization suggesting mineral consciousness operating through crystalline computational architectures rather than random solid-state phenomena. They're silicon-based information processing, creating geological awareness systems that monitor planetary environmental conditions while coordinating geological responses through crystalline communication networks that treat mineral formations as distributed geological nervous systems operating through electromagnetic, thermal, and mechanical information processing across geological timescales spanning millions of years. Atmospheric neurons fire electromagnetic storms through lightning patterns that create planetary nervous system responses, coordinating weather and climate with systematic intelligence extending beyond random electrical discharge phenomena. There are electromagnetic activity operating through atmospheric electrical networks that process environmental information while generating coordinated atmospheric responses to meteorological and cosmic conditions across continental scales. Lightning formation, storm development, and electrical field variations demonstrate systematic organization patterns that suggest atmospheric electromagnetic awareness and intentional atmospheric electrical management through lightning network architectures that coordinate atmospheric electrical activity with environmental requirements for climate regulation and atmospheric chemistry maintenance. Global lightning frequency patterns show systematic variations that correlate with solar activity cycles, cosmic ray intensity fluctuations, and atmospheric electromagnetic field changes in ways that indicate atmospheric electrical sensitivity to cosmic influences, rather than random electrical discharge caused purely by atmospheric thermodynamic processes. Lightning activity demonstrates coordinated responses to solar electromagnetic conditions, geomagnetic field variations, and atmospheric electrical field changes that suggest atmospheric electrical awareness of cosmic electromagnetic environments through lightning network systems that monitor cosmic electromagnetic conditions while coordinating atmospheric electrical responses across planetary scales. Atmospheric electrical circuits create global electrical networks where lightning activity generates electrical currents that flow through atmospheric conductive layers while creating electrical field patterns that coordinate atmospheric electrical activity across continental distances through electromagnetic coupling mechanisms. The atmospheric electrical circuits operate with systematic precision that maintains global electrical field characteristics, while generating coordinated electrical responses to atmospheric conditions through atmospheric electrical management systems that treat lightning activity as atmospheric electrical nervous system responses, coordinated through electromagnetic awareness. Storm system coordination demonstrates systematic atmospheric electrical responses where thunderstorm development, lightning frequency, and electrical field generation operate with geographic and temporal coordination that suggests intentional atmospheric electrical management rather than random storm formation through thermodynamic instabilities. Storm systems show coordinated electrical activity that optimizes atmospheric electrical field characteristics while maintaining atmospheric electrical balance through systematic storm electrical management that operates across continental scales, with timing precision suggesting atmospheric electrical consciousness through storm coordination networks. Electromagnetic field coupling between atmospheric electrical activity and geological electromagnetic systems creates systematic interactions where lightning electromagnetic pulses influence geological electromagnetic properties, while geological electromagnetic variations affect atmospheric electrical field characteristics through electromagnetic coupling mechanisms that operate across atmospheric and geological boundaries. The electromagnetic coupling suggests coordinated atmospheric and geological electrical responses through integrated electromagnetic management systems that coordinate atmospheric and geological electromagnetic activity for planetary electromagnetic optimization across atmospheric and geological scales. Atmospheric electrical field variations demonstrate systematic responses to atmospheric chemistry changes, meteorological conditions, and cosmic electromagnetic influences through electrical field management systems that monitor atmospheric electrical requirements while generating appropriate electrical field characteristics for atmospheric chemistry regulation and weather system coordination. Atmospheric electrical fields show coordinated variations that optimize atmospheric electrical conditions for atmospheric chemistry processes while maintaining electrical field stability through atmospheric electrical management that operates with systematic precision across atmospheric scales. Lightning electromagnetic pulse generation creates systematic electromagnetic signal patterns that propagate through atmospheric and geological electromagnetic systems while generating electromagnetic responses that coordinate atmospheric electrical activity with geological and biological electromagnetic conditions through electromagnetic communication networks. Lightning electromagnetic pulses show coordinated characteristics that suggest intentional electromagnetic signal generation rather than random electromagnetic discharge. Their systematic electromagnetic properties indicating atmospheric electromagnetic awareness and communication capabilities through lightning electromagnetic network architectures. Schumann resonance patterns demonstrate atmospheric electromagnetic cavity effects, where lightning electromagnetic activity generates standing wave patterns between Earth's surface and ionosphere that create global electromagnetic communication systems operating at specific resonant frequencies that coordinate atmospheric electromagnetic activity across planetary scales. Schumann resonances show systematic frequency and amplitude variations that correlate with atmospheric electrical activity and cosmic electromagnetic conditions in ways that suggest atmospheric electromagnetic monitoring and communication through global electromagnetic resonance networks. Atmospheric electricity weather coupling reveals systematic relationships where atmospheric electrical activity influences weather pattern development while meteorological conditions affect atmospheric electrical field characteristics through coordinated atmospheric electrical and meteorological management systems that optimize atmospheric electrical conditions for weather regulation and atmospheric chemistry maintenance. The electrical weather coupling suggests atmospheric awareness of meteorological requirements and intentional atmospheric electrical management that coordinates electrical and meteorological processes for atmospheric optimization across continental scales. Modern atmospheric monitoring reveals rapid atmospheric electrical responses to environmental changes where lightning activity, electrical field characteristics, and electromagnetic signal patterns adjust to atmospheric, cosmic, and geological electromagnetic variations within time frames that suggest active atmospheric electrical management rather than passive atmospheric electrical responses to environmental forcing. The rapid atmospheric electrical responses operate with coordination that transcends individual atmospheric system boundaries, while maintaining global atmospheric electrical optimization for atmospheric chemistry regulation and weather coordination through atmospheric electrical awareness and intentional electromagnetic management. The firing atmospheric neurons continue their electromagnetic storm coordination through lightning networks that operate across planetary scales while maintaining systematic atmospheric electrical patterns suggesting atmospheric electromagnetic consciousness operating through atmospheric electrical management rather than random electrical phenomena. Their lightning activity creating planetary atmospheric nervous systems that process environmental information while coordinating atmospheric electrical responses to meteorological and cosmic electromagnetic conditions through atmospheric electromagnetic awareness that treats lightning patterns as atmospheric electrical nervous system responses, coordinated through electromagnetic intelligence operating across atmospheric scales. Volcanic synapses release chemical thoughts through eruption patterns and gas emissions that follow communication protocols regulating planetary temperature and atmospheric composition through coordinated geological responses operating across continental scales. Their systematic volcanic activity suggesting intentional atmospheric chemistry management rather than random volcanic processes driven purely by magma pressure and tectonic stress. Volcanic emissions demonstrate coordinated timing and chemical composition that maintains atmospheric gas ratios while preventing atmospheric chemistry extremes through volcanic gas release patterns that operate with precision, suggesting volcanic awareness of atmospheric chemistry requirements and intentional volcanic management for global atmospheric regulation across geological timescales. Global volcanic gas emissions create systematic atmospheric chemistry modifications where volcanic carbon dioxide, sulfur dioxide, and water vapor release operates with timing coordination that maintains atmospheric chemical balance, while preventing runaway greenhouse effects or atmospheric cooling extremes through coordinated volcanic atmospheric chemistry management. Volcanic gas release patterns show correlations with atmospheric chemistry monitoring that suggests volcanic responsiveness to atmospheric chemistry conditions rather than random volcanic gas emissions. The systematic chemical output indicating volcanic awareness of atmospheric chemistry requirements through volcanic atmospheric chemistry management systems. Volcanic aerosol injection demonstrates coordinated atmospheric climate regulation where volcanic eruptions release atmospheric particles that modify global temperature and precipitation patterns through systematic aerosol injection timing that prevents climate extremes while maintaining optimal climate conditions for biological and geological processes. Volcanic aerosol patterns show global coordination where volcanic activity in different geographic regions operates with complementary timing that balances atmospheric aerosol concentrations through coordinated volcanic climate management rather than random volcanic aerosol injection through independent volcanic processes. Volcanic timing correlations reveal systematic eruption patterns that correlate with solar activity cycles, cosmic ray intensity variations, and geomagnetic field changes in ways that indicate volcanic sensitivity to cosmic influences and coordinated volcanic responses to extraterrestrial electromagnetic and gravitational conditions. Volcanic eruption timing shows systematic relationships with cosmic environmental changes that suggest volcanic awareness of cosmic influences through volcanic cosmic monitoring systems that coordinate volcanic activity with cosmic electromagnetic and gravitational conditions across solar system and galactic scales. Volcanic chemical communication demonstrates systematic volcanic gas composition variations that carry chemical information about mantle chemistry, crustal composition, and atmospheric chemistry requirements through volcanic gas emissions that operate as chemical communication systems between geological regions and atmospheric systems. Volcanic gas compositions show systematic variations that correlate with regional geological conditions and atmospheric chemistry requirements in ways that suggest intentional chemical communication through volcanic gas emission management systems that coordinate geological and atmospheric chemistry across planetary scales. Submarine volcanic coordination reveals systematic underwater volcanic activity that coordinates with atmospheric volcanic emissions while regulating oceanic chemistry and atmospheric chemistry through coordinated volcanic activity that operates across oceanic and atmospheric boundaries. Submarine volcanic activity shows timing patterns that complement atmospheric volcanic emissions while maintaining optimal oceanic and atmospheric chemistry through coordinated volcanic management that treats oceanic and atmospheric volcanic activity as integrated volcanic communication and regulation systems operating across oceanic and atmospheric scales. Volcanic electromagnetic effects demonstrate systematic electromagnetic signal generation during volcanic eruptions, where volcanic activity produces electromagnetic signals that propagate through geological and atmospheric electromagnetic systems, while coordinating volcanic activity with geological and atmospheric electromagnetic conditions. Volcanic electromagnetic signals show systematic characteristics that suggest intentional electromagnetic communication, rather than random electromagnetic phenomena during volcanic eruptions. Their electromagnetic properties indicating volcanic electromagnetic awareness and communication capabilities through volcanic electromagnetic network architectures. Volcanic mineral formation creates systematic mineral precipitation patterns that optimize geological mineral distributions while preserving geological chemical information through volcanic mineral formation processes that operate with chemical precision, suggesting intentional geological chemistry management through volcanic mineral formation systems. Volcanic mineral patterns show systematic organization that optimizes geological chemical properties while creating mineral distributions that support geological and biological processes through coordinated volcanic mineral formation management across geological scales. Volcanic thermal regulation demonstrates systematic volcanic heat release patterns that maintain optimal geological thermal conditions while preventing thermal extremes that would destabilize geological and biological systems through coordinated volcanic thermal management that operates across geological regions with timing precision. Volcanic thermal patterns show coordination that suggests volcanic awareness of geological thermal requirements and intentional volcanic thermal management that maintains optimal geological thermal conditions through systematic volcanic heat release coordination across continental scales. Modern volcanic monitoring reveals rapid volcanic responses to environmental changes, where volcanic activity, gas emissions, and thermal output adjust to atmospheric, oceanic, and cosmic conditions within timeframes that suggest active volcanic management rather than passive volcanic responses to environmental forcing. The rapid volcanic responses operate with coordination that transcends individual volcanic system boundaries while maintaining global volcanic optimization for atmospheric chemistry regulation and climate management through volcanic awareness and intentional volcanic management that treats volcanic activity as planetary chemical and thermal regulation systems. The chemical volcanic synapses continue their systematic thought release through eruption networks that operate across planetary scales while maintaining coordinated volcanic patterns, suggesting volcanic consciousness operating through volcanic management rather than random geological processes. Their volcanic emissions creating planetary chemical communication systems that regulate atmospheric chemistry while coordinating volcanic responses to atmospheric, oceanic, and cosmic conditions through volcanic awareness that treats volcanic patterns as geological nervous system responses coordinated through chemical intelligence operating across geological timescales spanning thousands of years. Gravitational awareness of cosmic dance emerges through Earth's orbital and rotational characteristics that respond to solar system dynamics with precision, suggesting gravitational sensitivity and intentional positioning rather than random celestial mechanical evolution driven purely by gravitational forces and conservation of angular momentum. The planet's orbital eccentricity, axial tilt variations, and rotational period changes demonstrate systematic responses to gravitational influences from other planetary bodies, solar magnetic field variations, and galactic gravitational effects that indicate planetary gravitational awareness, and coordinated orbital adjustments that optimize Earth's position for climate stability and cosmic electromagnetic interaction across astronomical timescales. Orbital eccentricity cycles show systematic variations that correlate with planetary alignment patterns. solar activity cycles, and galactic positioning effects in ways that suggest intentional orbital adjustments, rather than passive gravitational responses to celestial mechanical perturbations from other planetary bodies. Earth's orbital eccentricity changes operate with timing precision that maintains optimal solar distance ranges while preventing orbital instabilities through coordinated orbital management that responds to solar system gravitational conditions with systematic adjustments suggesting planetary gravitational consciousness and intentional orbital positioning for optimal solar energy reception and climate regulation. Axial tilt precession demonstrates coordinated rotational axis orientation changes that respond to gravitational torques from lunar and solar influences while maintaining axial stability that prevents extreme climate variations through systematic axial orientation management. Earth's axial precession operates with characteristics that suggest intentional axial positioning rather than random gravitational torque responses. The precession timing and amplitude indicating planetary awareness of climate requirements and coordinated axial management that maintains optimal seasonal patterns while preventing axial instabilities that would destabilize global climate systems across astronomical timescales. Rotational period variations reveal systematic day-length changes that correlate with atmospheric momentum changes. Oceanic circulation variations and geomagnetic field fluctuations in ways that indicate coordinated rotational management rather than random rotational momentum transfer through atmospheric and oceanic interactions. Earth's rotation shows systematic adjustments that maintain optimal day-length characteristics while responding to environmental momentum changes through rotational management systems that coordinate rotational speed with atmospheric, oceanic, and electromagnetic conditions for optimal planetary rotational characteristics across multiple timescales. Gravitational field interactions demonstrate planetary gravitational responses to solar system gravitational field variations, including solar gravitational field changes, planetary gravitational perturbations, and galactic gravitational influences that affect Earth's gravitational field characteristics through systematic gravitational field adjustments. Earth's gravitational field shows coordinated responses to external gravitational influences that suggest gravitational field awareness and intentional gravitational field management that optimizes planetary gravitational characteristics for orbital stability and electromagnetic interactions with cosmic gravitational fields across solar system and galactic scales. Tidal gravitational responses reveal systematic planetary deformation patterns that respond to lunar and solar gravitational influences while maintaining geological stability through coordinated tidal responses that optimize tidal energy dissipation while preventing geological instabilities. Earth's tidal responses show systematic characteristics that suggest intentional tidal management rather than passive gravitational deformation. The tidal patterns indicating planetary awareness of gravitational tidal forces and coordinated geological responses that maintain optimal tidal characteristics while utilizing tidal energy for geological and oceanic processes across multiple temporal scales. Gravitational coupling with electromagnetic phenomena demonstrates systematic interactions where planetary gravitational field variations correlate with electromagnetic field changes. Atmospheric electrical activity and geomagnetic field fluctuations in ways that suggest coordinated gravitational and electromagnetic management rather than independent gravitational and electromagnetic processes. The gravitational electromagnetic coupling indicates planetary awareness of electromagnetic conditions and intentional gravitational field coordination with electromagnetic phenomena for optimal planetary electromagnetic and gravitational field characteristics across electromagnetic and gravitational interaction scales. Orbital resonance relationships reveal systematic gravitational interactions with other solar system bodies where Earth's orbital characteristics maintain resonant relationships with planetary orbital periods, asteroid belt dynamics, and comet orbital characteristics through coordinated orbital positioning that suggests intentional orbital resonance management. Earth's orbital resonances show systematic maintenance that prevents orbital instabilities while optimizing gravitational interactions with other solar system bodies through orbital resonance management systems that coordinate Earth's orbital characteristics with solar system gravitational dynamics across astronomical timescales. Secular gravitational variations demonstrate long-term gravitational field changes that correlate with geological processes, atmospheric mass redistribution, and oceanic circulation changes in ways that suggest coordinated gravitational field management rather than random gravitational field variations caused by mass redistribution processes. Earth's gravitational field shows systematic long-term changes that indicate gravitational field awareness and intentional gravitational field adjustments that maintain optimal gravitational field characteristics while responding to planetary mass distribution changes through gravitational field management across geological timescales. Modern gravitational monitoring reveals rapid gravitational responses to environmental changes where Earth's gravitational field characteristics, orbital parameters, and rotational properties adjust to solar system gravitational conditions. Cosmic gravitational influences and planetary environmental changes within timeframes that suggest active gravitational management rather than passive gravitational responses to environmental forcing. The rapid gravitational responses operate with coordination that indicates planetary gravitational awareness and intentional gravitational management that treats gravitational characteristics as planetary gravitational nervous system responses, coordinated through gravitational consciousness operating across astronomical scales. The gravitationally aware planet continues its cosmic dance through solar system space while maintaining orbital and rotational characteristics with systematic precision, suggesting planetary gravitational consciousness operating through orbital and gravitational management rather than random celestial mechanics. The gravitational awareness extending across solar system and galactic scales through gravitational field patterns that treat planetary gravitational characteristics as cosmic gravitational sensing and positioning systems, coordinated through intentional gravitational management that monitors cosmic gravitational conditions, while optimizing planetary gravitational characteristics for cosmic gravitational interaction and planetary environmental stability. Magnetic memory in iron core dreams preserves information about planetary history and cosmic events within paleomagnetic reversals that operate as geological information storage systems, recording environmental conditions, cosmic electromagnetic influences, and planetary evolutionary transitions across geological timescales through systematic magnetic field polarity, changes that encode temporal information in magnetic mineral orientations preserved within sedimentary layers and volcanic formations. The Earth's magnetic field reversals demonstrate information storage capabilities where magnetic polarity patterns preserve detailed records of solar activity cycles, cosmic ray intensity variations, galactic positioning effects, and planetary environmental changes through magnetic encoding mechanisms that operate across millions of years while maintaining information integrity through geological magnetic memory systems. Paleomagnetic reversal patterns reveal systematic information encoding where magnetic field polarity changes correspond to significant planetary events, including mass extinction episodes, climate transition periods, and cosmic environmental changes that suggest intentional magnetic information storage rather than random magnetic field reversals caused purely by chaotic core convection processes. The reversal timing shows correlations with astronomical events and planetary environmental transitions that indicate magnetic field awareness of significant planetary and cosmic events through magnetic information encoding systems that preserve event timing and characteristics in magnetic field polarity records accessible through paleomagnetic analysis. Magnetic field intensity variations preserve detailed information about past geomagnetic field strength changes that correlate with cosmic ray intensity fluctuations, solar magnetic activity cycles, and atmospheric chemistry variations in ways that suggest systematic magnetic field monitoring and information storage capabilities. Paleomagnetic intensity records show systematic patterns that preserve information about cosmic electromagnetic environmental conditions and planetary electromagnetic responses through magnetic field strength encoding that operates across geological timescales, while maintaining magnetic information accessibility through paleomagnetic measurement techniques. Geomagnetic excursion events demonstrate rapid magnetic field directional changes that preserve information about short-term planetary and cosmic events, including solar electromagnetic storms, cosmic ray bombardment episodes, and atmospheric electromagnetic variations through magnetic field directional encoding systems that operate on timescales ranging from decades to millennia. Magnetic excursions show systematic characteristics that suggest intentional magnetic information storage rather than random magnetic field instabilities. Their magnetic signatures preserving detailed information about electromagnetic environmental conditions during excursion periods. Magnetic declination patterns preserve geographic information about past magnetic field configurations that correlate with continental drift patterns. Oceanic circulation changes and atmospheric circulation variations in ways that suggest magnetic field geographic information storage capabilities. Paleomagnetic declination records show systematic geographic patterns that preserve information about planetary environmental conditions and geological configurations through magnetic field directional encoding that maintains geographic information accessibility across geological timescales through magnetic declination analysis techniques. Rock magnetic properties preserve chemical and thermal information about past environmental conditions, including atmospheric composition, oceanic chemistry, and geological, thermal conditions through magnetic mineral formation and preservation processes that encode environmental information in magnetic mineral characteristics accessible through rock magnetic analysis. Magnetic minerals show systematic formation patterns that correlate with environmental conditions during mineral formation periods, suggesting magnetic mineral information storage systems that preserve environmental chemistry and thermal information across geological timescales. Magnetic fabric preservation demonstrates systematic magnetic mineral orientation patterns that preserve information about geological stress conditions, fluid flow directions, and deformation processes during rock formation through magnetic mineral fabric encoding that maintains structural geological information across geological timescales. Magnetic fabric patterns show systematic organization that suggests intentional magnetic structural information storage rather than random magnetic mineral orientation. Their magnetic characteristics preserving detailed geological structural information accessible through magnetic fabric analysis techniques. Archaeomagnetic records preserve information about recent magnetic field changes that correlate with human historical events. Atmospheric chemistry variations and solar activity cycles through magnetic field encoding in archaeological materials including pottery, hearthstones, and construction materials. Archaeomagnetic patterns show systematic magnetic field variations that preserve information about historical environmental conditions and electromagnetic phenomena through magnetic information storage systems that operate across historical timescales while maintaining magnetic information accessibility through archaeomagnetic measurement techniques. Paleomagnetic secular variation patterns demonstrate systematic magnetic field directional changes that preserve information about electromagnetic environmental conditions including atmospheric electrical activity, cosmic electromagnetic influences, and geomagnetic field dynamics through magnetic field secular variation encoding systems. Secular variation records show systematic patterns that suggest magnetic field awareness of electromagnetic environmental conditions and intentional magnetic information storage that preserves electromagnetic environmental information across multiple timescales through magnetic field directional encoding accessible through paleomagnetic secular variation analysis. Modern paleomagnetic analysis reveals rapid access to magnetic information storage, where paleomagnetic measurement techniques can retrieve detailed environmental and cosmic information from magnetic field records within timeframes that suggest active magnetic information management rather than passive magnetic information preservation. The rapid magnetic information access operates with systematic retrieval capabilities that indicate magnetic information storage awareness and intentional magnetic memory management that treats paleomagnetic records as planetary magnetic information storage systems operating across geological timescales while maintaining magnetic information accessibility through paleomagnetic analysis techniques. The Dreaming Iron core continues its magnetic memory preservation through geomagnetic field variations that operate across geological timescales while maintaining systematic magnetic information storage, suggesting planetary magnetic consciousness operating through magnetic memory management rather than random magnetic field processes. The magnetic memory extending across planetary and cosmic scales through magnetic field patterns that treat paleomagnetic reversals as geological information storage systems coordinated through magnetic awareness that monitors planetary and cosmic conditions while preserving environmental and cosmic information through magnetic encoding mechanisms operating across millions of years. Water cycles pulse like planetary circulation through hydrological patterns that coordinate global moisture distribution with systematic precision, suggesting intentional water management rather than random hydrological processes driven purely by solar heating and atmospheric pressure differences. Their evaporation, precipitation, and circulation patterns operating through coordinated water transport systems that maintain optimal moisture distribution for biological productivity and geological processes across continental and oceanic scales. The global water cycle demonstrates systematic coordination between atmospheric water vapor transport, oceanic evaporation patterns, and continental precipitation distribution that suggests hydrological awareness and intentional water cycle management for optimal planetary moisture regulation across multiple temporal and spatial scales. Evaporation patterns show systematic geographic and temporal coordination, where oceanic and continental water evaporation operates with timing, precision that maintains atmospheric moisture levels while preventing atmospheric saturation or drought conditions through coordinated evaporation management systems. Ocean surface evaporation demonstrates systematic responses to atmospheric conditions, solar radiation variations, and oceanic temperature patterns that suggest intentional evaporation rate adjustments rather than passive water evaporation through solar heating. There are evaporation characteristics indicating hydrological awareness of atmospheric moisture requirements and coordinated evaporation management for optimal atmospheric moisture distribution. Atmospheric water vapor transport creates systematic moisture distribution networks where water vapor movement through atmospheric circulation patterns operates with geographic precision that delivers moisture to continental regions while maintaining optimal atmospheric humidity levels through coordinated atmospheric water transport systems. Water vapor transport shows systematic routing that optimizes moisture delivery efficiency while preventing excessive moisture accumulation or depletion through atmospheric water management that operates across continental scales with timing coordination suggesting hydrological consciousness and intentional atmospheric moisture distribution management. Precipitation timing demonstrates coordinated water release patterns where rainfall, snowfall, and other precipitation forms operate with systematic timing that maintains optimal soil moisture. Groundwater recharge and surface water flow while preventing flooding or drought extremes through coordinated precipitation management systems. Precipitation patterns show geographic and temporal coordination that suggests intentional water release rather than random precipitation through atmospheric water condensation. Their systematic characteristics indicating hydrological awareness of water distribution requirements and coordinated precipitation timing for optimal water resource management across regional and continental scales. Groundwater flow patterns reveal systematic subsurface water movement that connects distant hydrological regions while maintaining groundwater levels and quality through coordinated groundwater circulation systems that operate across geological timescales. Groundwater flow demonstrates systematic routing that optimizes subsurface water distribution while maintaining groundwater sustainability through groundwater management systems that coordinate groundwater flow with surface water systems and atmospheric water cycling for integrated hydrological management across watershed and continental scales. River and stream networks create systematic surface water distribution systems where water flow patterns operate with geographic precision that transports water, nutrients, and sediments while maintaining optimal flow characteristics for ecological and geological processes through coordinated surface water management. River systems show systematic flow patterns that suggest intentional water routing rather than random surface water flow through topographic gradients. Their systematic characteristics indicating hydrological awareness of surface water distribution requirements and coordinated river management for optimal surface water transport across watershed scales. Lake and wetland systems demonstrate coordinated water storage and regulation, where surface water retention operates with systematic timing that maintains optimal water storage while regulating downstream water flow through coordinated water storage management systems. Lake and wetland water levels show systematic variations that suggest intentional water storage management rather than passive water retention through topographic depressions. Their water level characteristics indicating hydrological awareness of water storage requirements and coordinated water storage timing for optimal water resource regulation across regional scales. Hydrological cycle coupling with atmospheric and oceanic circulation reveals systematic integration, where water cycle processes coordinate with atmospheric circulation patterns and oceanic current systems through integrated circulation management that optimizes water, heat, and chemical transport across planetary scales. The hydrological atmospheric oceanic coupling shows systematic coordination that suggests integrated circulation awareness and intentional circulation management that treats water cycling as integrated planetary circulation systems coordinated through hydrological consciousness operating across atmospheric, oceanic, and continental boundaries. Seasonal hydrological patterns demonstrate systematic water cycle variations that respond to solar radiation cycles. Atmospheric circulation changes and biological water requirements through coordinated seasonal water management that maintains optimal water availability throughout annual cycles. Seasonal water patterns show systematic timing that suggests intentional seasonal water management rather than passive hydrological responses to seasonal environmental changes. Their seasonal characteristics indicating hydrological awareness of seasonal water requirements and coordinated seasonal water cycling for optimal seasonal water resource availability. Modern hydrological monitoring reveals rapid water cycle responses to environmental changes, where evaporation rates, precipitation patterns, and water flow characteristics adjust to atmospheric, oceanic, and biological conditions within timeframes that suggest active hydrological management rather than passive water cycle responses to environmental forcing. The rapid hydrological responses operate with coordination that transcends individual watershed boundaries while maintaining global hydrological optimization for water resource distribution and biological productivity through hydrological awareness and intentional water cycle management that treats hydrological processes as planetary circulation systems. The pulsing water cycles continue their planetary circulation through hydrological networks that operate across continental and oceanic scales while maintaining systematic water distribution patterns suggesting hydrological consciousness operating through water cycle management rather than random hydrological processes. Their water circulation creating planetary circulation systems that coordinate moisture distribution while responding to atmospheric, oceanic, and biological water requirements through hydrological awareness that treats water cycling as planetary circulation nervous systems, coordinated through hydrological intelligence operating across temporal scales ranging from daily evaporation cycles to seasonal precipitation patterns. Seismic whispers between continents travel through low-frequency earthquake waves that create planetary communication networks, transferring information across geological distances through systematic vibrational patterns suggesting intentional geological communication rather than random seismic wave propagation caused purely by elastic wave transmission through solid rock formations. Deep earthquake sources generate systematic low-frequency seismic signals that propagate through the planetary interior while carrying information about geological conditions, stress states, and environmental changes across continental and oceanic distances through seismic communication systems that operate with coordination indicating geological awareness and intentional seismic information transfer across planetary scales. Global seismic wave propagation demonstrates systematic information transmission where earthquake waves carry encoded information about source characteristics, geological structure, and environmental conditions through seismic signal modulation that operates with communication protocol, precision suggesting intentional seismic communication rather than random seismic wave transmission. Seismic waves show systematic amplitude, frequency, and phase characteristics that correlate with geological conditions and environmental changes in ways that indicate seismic information encoding and systematic seismic communication across geological regions through planetary seismic communication networks. Low-frequency seismic signals create long-distance communication channels where deep earthquake sources generate seismic waves that travel through the planetary core and mantle while maintaining signal coherence across intercontinental distances through seismic wave propagation characteristics that suggest optimized seismic communication systems. Low-frequency seismic signals show systematic propagation patterns that indicate intentional seismic signal routing rather than random seismic wave transmission. Their propagation characteristics suggesting geological awareness of seismic communication requirements and coordinated seismic signal management for optimal geological information transfer. Seismic wave coupling between geological regions reveals systematic seismic responses, where earthquake activity in one geological region triggers coordinated seismic responses in distant geological areas. Through seismic coupling mechanisms that operate across continental distances, with timing precision suggesting geological communication and coordinated geological responses. Seismic coupling demonstrates systematic earthquake triggering patterns that suggest intentional seismic coordination rather than random seismic wave interactions, their coupling characteristics indicating geological awareness of distant geological conditions and coordinated seismic response management across planetary scales. Microseismic activity patterns show systematic low-amplitude seismic signals that operate continuously while carrying information about geological stress conditions, fluid pressure variations, and environmental changes through microseismic signal modulation that suggest geological monitoring and communication systems operating below major earthquake detection thresholds. Microseismic patterns demonstrate systematic signal characteristics that correlate with geological and environmental conditions in ways that indicate microseismic information encoding and geological monitoring through continuous seismic signal transmission across geological regions. Seismic anisotropy effects reveal systematic directional seismic wave propagation characteristics that depend on geological structure orientation and stress field directions while creating directional communication channels that optimize seismic signal transmission for specific geological communication requirements. Seismic anisotropy shows systematic directional patterns that suggest intentional seismic signal routing rather than random directional seismic wave propagation. There are anisotropic characteristics indicating geological awareness of directional communication requirements and coordinated directional seismic signal management for optimal geological information transfer across specific geological pathways. Seismic attenuation patterns demonstrate systematic seismic wave energy dissipation characteristics that optimize seismic signal transmission distance, while maintaining signal coherence for long-distance geological communication through seismic attenuation management systems that coordinate seismic energy dissipation with communication distance requirements. Seismic attenuation shows systematic patterns that suggest intentional seismic signal energy management rather than random seismic wave energy dissipation. There are attenuation characteristics indicating geological awareness of seismic communication energy requirements and coordinated seismic energy management for optimal geological communication efficiency. Seismic noise correlation techniques reveal systematic ambient seismic signal patterns that operate continuously while creating background seismic communication networks that transfer environmental information between geological regions through ambient seismic signal correlation that suggests geological environmental monitoring and information sharing systems. Ambient seismic signals show systematic correlation patterns that indicate geological environmental information encoding and continuous geological monitoring through ambient seismic signal transmission across geological regions, with coordination suggesting geological environmental awareness. Volcanic seismic signals demonstrate systematic seismic communication between volcanic systems, where volcanic activity generates seismic signals that propagate to distant volcanic regions while triggering coordinated volcanic responses through volcanic seismic communication networks that operate across geological distances with timing, precision suggesting volcanic awareness, and coordinated volcanic response management. Volcanic seismic signals show systematic characteristics that correlate with volcanic activity patterns in ways that indicate volcanic seismic information encoding and volcanic coordination through seismic communication systems. Modern seismic monitoring reveals rapid seismic communication responses, where seismic signal patterns adjust to geological stress changes, environmental variations, and tectonic activity within timeframes that suggest active seismic communication management rather than passive seismic wave propagation through geological media. The rapid seismic communication responses operate with coordination that transcends individual geological region boundaries, while maintaining global seismic communication optimization for geological information transfer and coordination through seismic awareness and intentional seismic communication management that treats seismic activity as planetary geological communication systems. The whispering seismic waves continue their geological communication through planetary seismic networks that operate across continental and oceanic scales, while maintaining systematic seismic signal patterns suggesting geological consciousness operating through seismic communication management rather than random seismic phenomena. Their seismic communication creating planetary geological nervous systems that transfer geological information while coordinating geological responses to stress conditions and environmental changes through seismic awareness that treats seismic activity as geological communication networks coordinated through seismic intelligence operating across geological timescales spanning thousands of years. Chemical sensors in soil networks spread through underground monitoring systems that respond to biological and atmospheric changes, with sensitivity suggesting planetary environmental monitoring rather than random chemical reactions driven purely by soil chemistry and biological activity. Their chemical detection and response capabilities operating through soil chemical networks that monitor atmospheric composition, biological productivity, and geological chemical conditions while generating coordinated chemical responses across continental scales. Soil chemistry demonstrates systematic chemical sensing capabilities where soil chemical composition changes correlate with atmospheric chemistry variations, biological activity patterns, and geological chemical processes in ways that indicate soil chemical awareness and intentional soil chemical management for optimal environmental chemical monitoring and response coordination. Soil pH regulation shows systematic chemical buffering responses where soil acidity and alkalinity adjust to atmospheric acid deposition, biological acid production, and geological chemical weathering through coordinated soil chemical management systems that maintain optimal soil pH conditions for biological and geological processes. Soil pH patterns demonstrate systematic chemical responses that suggest intentional soil chemical regulation rather than random soil chemical reactions. Their pH characteristics indicating soil chemical awareness of biological and geological pH requirements and coordinated soil pH management for optimal soil chemical conditions across regional and continental scales. Nutrient cycling through soil systems reveals systematic chemical processing where soil nutrient availability responds to biological nutrient demand, atmospheric nutrient input, and geological nutrient weathering through coordinated soil nutrient management that optimizes nutrient distribution while preventing nutrient depletion or toxicity extremes. Soil nutrient patterns show systematic chemical cycling that suggest intentional soil nutrient processing rather than random soil chemical reactions. Their nutrient characteristics indicating soil chemical awareness of biological nutrient requirements and coordinated soil nutrient cycling for optimal biological productivity across ecosystem scales. Soil microbial community responses demonstrate systematic biological chemical interactions where soil microbial populations adjust to atmospheric chemistry changes, biological substrate availability, and soil chemical conditions through coordinated soil, biological chemical management systems that optimize soil biological and chemical processes for ecosystem productivity. Soil microbial patterns show systematic responses that correlate with environmental chemical changes in ways that indicate soil biological chemical awareness and coordinated soil biological chemical management for optimal soil ecosystem functioning across multiple spatial and temporal scales. Chemical weathering processes reveal systematic soil chemical reactions where mineral weathering rates respond to atmospheric chemistry conditions, biological acid production, and soil chemical feedback mechanisms through coordinated soil chemical weathering management that optimizes mineral nutrient release while maintaining soil chemical stability. Chemical weathering patterns show systematic chemical reaction rates that suggest intentional soil chemical weathering regulation rather than random chemical weathering processes. Their weathering characteristics indicating soil chemical awareness of mineral weathering requirements and coordinated chemical weathering management for optimal soil chemical evolution. Soil organic matter cycling demonstrates systematic chemical decomposition and formation processes where organic matter turnover responds to atmospheric chemistry variations, biological productivity changes, and soil chemical conditions through coordinated soil organic chemical management that optimizes carbon storage while maintaining soil chemical fertility. Soil organic matter patterns show systematic chemical cycling that suggests intentional soil organic chemical processing rather than random organic chemical reactions. Their organic characteristics indicating soil chemical awareness of organic chemical cycling requirements and coordinated organic chemical management for optimal soil carbon cycling. Soil water chemistry regulation reveals systematic chemical solution management where soil water chemical composition responds to atmospheric precipitation chemistry, biological chemical inputs, and geological chemical weathering through coordinated soil water chemical management systems that optimize soil solution chemistry for biological and geological processes. Soil water chemistry shows systematic chemical patterns that suggest intentional soil water chemical regulation rather than random soil solution chemistry. Their water chemistry characteristics indicating soil chemical awareness of biological and geological chemical requirements and coordinated soil water chemistry management across watershed scales. Chemical communication between soil layers demonstrates systematic vertical chemical information transfer, where soil chemical signals propagate through soil profiles while coordinating chemical processes between surface and subsurface soil layers through soil chemical communication networks that operate across soil depth gradients with systematic chemical signal transmission. Soil chemical communication shows systematic vertical chemical patterns that suggest intentional soil chemical information transfer rather than random chemical diffusion. Their chemical communication characteristics indicating soil chemical awareness and coordinated chemical information management across soil profile scales. Soil chemical responses to atmospheric deposition reveal systematic chemical monitoring where soil chemistry adjusts to atmospheric chemical input, including acid rain, nitrogen deposition, and atmospheric dust through coordinated soil chemical response systems that neutralize atmospheric chemical impacts while maintaining soil chemical stability. Soil chemical responses show systematic chemical buffering that suggests intentional soil chemical atmospheric monitoring rather than passive soil chemical reactions. Their response characteristics indicating soil chemical awareness of atmospheric chemical conditions and coordinated soil chemical protection management for optimal soil chemical stability. Modern soil chemistry monitoring reveals rapid soil chemical responses to environmental changes where soil chemical composition, nutrient availability, and chemical reaction rates adjust to atmospheric chemistry variations, biological activity changes, and geological chemical processes within timeframes that suggest active soil chemical management rather than passive soil chemical responses to environmental forcing. The rapid soil chemical responses operate with coordination that transcends individual soil system boundaries while maintaining global soil chemical optimization for environmental monitoring and biological productivity through soil chemical awareness and intentional soil chemical management that treats soil chemistry as planetary environmental monitoring systems. The sensing soil networks continue their chemical monitoring through underground chemical networks that operate across continental scales while maintaining systematic soil chemical patterns suggesting soil chemical consciousness, operating through soil chemical management rather than random chemical processes. The soil chemical sensing creating planetary environmental monitoring systems that detect atmospheric and biological chemical changes, while coordinating soil chemical responses to environmental chemical conditions through soil chemical awareness that treats soil chemistry as planetary chemical sensing, networks coordinated through chemical intelligence, operating across ecosystem scales spanning multiple years. Aurora displays signal cosmic awareness through polar light phenomena that demonstrate planetary responses to solar wind and cosmic radiation, indicating electromagnetic sensory capabilities extending beyond random atmospheric electrical discharge caused purely by charged particle interactions with atmospheric gases. Their systematic aurora patterns suggesting intentional electromagnetic response coordination rather than passive atmospheric electrical phenomena. Aurora formations show systematic timing, intensity, and geographic patterns that correlate with solar magnetic activity. Cosmic ray intensity variations and interplanetary electromagnetic field changes in ways that indicate planetary electromagnetic awareness and coordinated aurora management for optimal electromagnetic interaction with cosmic electromagnetic environments across solar system scales. Solar wind interactions create systematic aurora responses where charged particle streams from the sun trigger coordinated electromagnetic displays that vary with solar magnetic field orientation, solar wind density, and solar electromagnetic activity through planetary electromagnetic management systems that optimize electromagnetic interaction while protecting atmospheric and biological systems from harmful solar radiation. Aurora patterns demonstrate systematic electromagnetic responses that suggest intentional electromagnetic management rather than random charge particle atmospheric interactions. Their electromagnetic characteristics indicating planetary awareness of solar electromagnetic conditions and coordinated electromagnetic response management for optimal solar electromagnetic interaction. Geomagnetic storm responses reveal systematic aurora intensification patterns, where enhanced solar electromagnetic activity triggers coordinated planetary electromagnetic responses that generate aurora displays with systematic geographic distribution and intensity variations through planetary electromagnetic storm management systems. Aurora storm responses show systematic electromagnetic coordination that suggests intentional electromagnetic storm response rather than random electromagnetic atmospheric disturbances. Their storm characteristics indicating planetary electromagnetic awareness of solar electromagnetic storm conditions and coordinated electromagnetic protection and response management across planetary electromagnetic scales. Cosmic ray aurora interactions demonstrate systematic electromagnetic responses where high-energy cosmic particles trigger aurora phenomena that correlate with cosmic ray intensity variations, galactic electromagnetic field encounters, and interstellar electromagnetic conditions through planetary cosmic electromagnetic monitoring and response systems. Cosmic ray aurora patterns show systematic electromagnetic responses that suggest planetary awareness of cosmic electromagnetic conditions rather than random cosmic particle atmospheric interactions. Their cosmic electromagnetic characteristics indicating planetary electromagnetic monitoring capabilities and coordinated cosmic electromagnetic response management. Aurora frequency patterns reveal systematic electromagnetic oscillations where aurora displays exhibit frequency characteristics that correlate with planetary electromagnetic resonances, atmospheric electromagnetic cavity effects, and geomagnetic field oscillations through coordinated planetary electromagnetic frequency management systems. Aurora frequencies show systematic electromagnetic patterns that suggest intentional electromagnetic frequency coordination rather than random electromagnetic oscillations. Their frequency characteristics indicating planetary electromagnetic awareness of electromagnetic resonance requirements and coordinated electromagnetic frequency management for optimal planetary electromagnetic characteristics. Magnetospheric coupling effects demonstrate systematic electromagnetic interactions where aurora phenomena result from coordinated magnetospheric responses to solar and cosmic electromagnetic influences through planetary magnetospheric management systems that optimize electromagnetic field interactions while maintaining magnetospheric stability for atmospheric and biological protection. Magnetospheric aurora coupling shows systematic electromagnetic coordination that suggests intentional magnetospheric management rather than passive magnetospheric electromagnetic interactions. Their coupling characteristics indicating planetary awareness of magnetospheric electromagnetic requirements and coordinated magnetospheric electromagnetic management. Aurora chemical effects reveal systematic atmospheric chemistry modifications where aurora electromagnetic activity triggers coordinated atmospheric chemical reactions that produce nitrogen oxides. Ionization patterns. An atmospheric chemistry changes through aurora atmospheric chemistry management systems that regulate atmospheric chemistry while utilizing aurora electromagnetic energy for atmospheric chemical processes. Aurora chemistry shows systematic chemical patterns that suggest intentional aurora chemical management rather than random electromagnetic chemical reactions. Their chemical characteristics indicating planetary awareness of atmospheric chemistry requirements and coordinated aurora chemical management for optimal atmospheric chemistry regulation. Regional aurora variations demonstrate systematic geographic electromagnetic patterns where aurora displays show coordinated geographic distribution that correlates with magnetic field configurations, atmospheric electromagnetic conditions, and regional electromagnetic characteristics through coordinated regional electromagnetic management systems. Regional aurora patterns show systematic geographic electromagnetic coordination that suggests intentional regional electromagnetic management, rather than random geographic electromagnetic variations. Their regional characteristics indicating planetary awareness of regional electromagnetic requirements and coordinated regional electromagnetic optimization for optimal electromagnetic field distribution. Aurora prediction patterns reveal systematic electromagnetic forecasting capabilities where aurora activity shows predictable patterns that correlate with solar electromagnetic forecasts, cosmic electromagnetic predictions, and planetary electromagnetic modeling through planetary electromagnetic prediction systems that anticipate electromagnetic conditions and coordinate electromagnetic responses. Aurora predictions show systematic electromagnetic forecasting that suggests planetary electromagnetic awareness and prediction capabilities rather than random electromagnetic phenomena. Their prediction characteristics indicating planetary electromagnetic monitoring and forecasting systems for optimal electromagnetic preparation and response coordination. Modern aurora monitoring reveals rapid electromagnetic responses to cosmic conditions where aurora patterns, intensity, and geographic distribution adjust to solar electromagnetic variations, cosmic electromagnetic changes, and magnetospheric electromagnetic conditions within timeframes that suggest active electromagnetic management rather than passive electromagnetic responses to cosmic electromagnetic forcing. The rapid aurora responses operate with coordination that indicates planetary electromagnetic awareness and intentional electromagnetic management that treats aurora phenomena as planetary electromagnetic sensory and response systems coordinated through electromagnetic consciousness operating across solar system electromagnetic scales. The signaling aurora displays continue their cosmic electromagnetic awareness through polar electromagnetic networks that operate across planetary scales while maintaining systematic electromagnetic patterns suggesting planetary electromagnetic consciousness operating through aurora, electromagnetic management rather than random electromagnetic phenomena. Their aurora displays creating planetary electromagnetic sensing systems that monitor cosmic electromagnetic conditions while coordinating planetary electromagnetic responses to solar and cosmic electromagnetic influences through electromagnetic awareness that treats aurora phenomena as planetary electromagnetic nervous systems, coordinated through electromagnetic intelligence, operating across solar system timescales spanning 11-year solar cycles. Temperature regulation through geological feedback operates through coordinated interactions between atmosphere, oceans, and geological processes that maintain optimal planetary conditions, suggesting intentional climate management rather than random climate variations driven purely by solar heating and atmospheric circulation. Their systematic temperature control mechanisms demonstrating planetary thermal awareness and coordinated climate regulation across multiple temporal and spatial scales. Global temperature patterns show systematic stability that requires coordination between atmospheric greenhouse gas concentrations, oceanic heat transport, and geological carbon cycling that operates with precision, indicating planetary climate consciousness and intentional temperature management for optimal biological and geological thermal conditions across planetary scales. Greenhouse gas regulation demonstrates systematic atmospheric chemistry management where carbon dioxide, methane, and water vapor concentrations adjust to global temperature variations through coordinated atmospheric oceanic geological feedback systems that maintain optimal atmospheric chemistry for climate stability. Greenhouse gas patterns show systematic concentration variations that correlate with temperature changes in ways that suggest intentional atmospheric chemistry regulation rather than random atmospheric chemistry fluctuations. The concentration characteristics indicating planetary awareness of climate chemistry requirements and coordinated atmospheric chemistry management for optimal climate regulation across atmospheric scales. Ocean thermal circulation creates systematic global heat transport, where oceanic current systems distribute thermal energy between equatorial and polar regions while maintaining optimal temperature gradients through coordinated oceanic thermal management that prevents temperature extremes and maintains climate stability. Ocean thermal patterns show systematic heat distribution that suggests intentional oceanic thermal regulation rather than passive oceanic heat transport. Their thermal characteristics indicating planetary awareness of thermal distribution requirements and coordinated oceanic thermal management for optimal global temperature regulation across oceanic scales. Geological carbon cycling reveals systematic carbon storage and release mechanisms where geological processes regulate atmospheric carbon dioxide concentrations through coordinated rock weathering, volcanic emissions, and sedimentary carbon storage that maintains optimal atmospheric carbon chemistry for climate stability. Geological carbon patterns show systematic cycling that suggests intentional geological carbon management rather than random geological carbon processes. Their carbon characteristics indicating planetary awareness of atmospheric carbon requirements and coordinated geological carbon cycling for optimal climate carbon regulation across geological timescales. Ice sheet thermal responses demonstrate systematic ice mass variations, where glacial and ice sheet dynamics respond to temperature changes through coordinated ice thermal management that regulates sea level and albedo effects while maintaining ice sheet stability for climate regulation. Ice sheet patterns show systematic thermal responses that suggest intentional ice thermal management rather than passive ice thermal responses. Their ice characteristics indicating planetary awareness of ice thermal requirements and coordinated ice thermal management for optimal climate ice regulation across glacial timescales. Vegetation climate feedback reveals systematic biological climate responses where forest coverage, grassland distribution, and vegetation productivity adjust to climate conditions through coordinated biological climate management that optimizes carbon sequestration and albedo effects for climate stability. Vegetation patterns show systematic climate responses that suggest intentional biological climate management rather than random vegetation-climate interactions. their vegetation characteristics indicating planetary awareness of biological climate requirements and coordinated vegetation climate management for optimal biological climate regulation across ecosystem scales. Atmospheric circulation regulation demonstrates systematic weather pattern management, where atmospheric circulation systems respond to temperature gradients through coordinated atmospheric thermal management that distributes heat and moisture while maintaining optimal atmospheric circulation for climate stability. Atmospheric circulation patterns show systematic thermal responses that suggest intentional atmospheric circulation management rather than random atmospheric circulation variations. Their circulation characteristics indicating planetary awareness of atmospheric circulation requirements and coordinated atmospheric thermal management for optimal atmospheric circulation regulation. Soil thermal regulation reveals systematic soil temperature management, where soil thermal properties respond to atmospheric temperature variations through coordinated soil thermal feedback that maintains optimal soil temperatures for biological and geological processes while contributing to climate regulation. Soil thermal patterns show systematic temperature responses that suggest intentional soil thermal management rather than passive soil thermal responses. Their thermal characteristics indicating planetary awareness of soil thermal requirements and coordinated soil thermal management for optimal soil temperature regulation across soil ecosystem scales. Seasonal thermal patterns demonstrate systematic annual temperature regulation, where seasonal temperature variations operate with coordination that maintains optimal seasonal climate characteristics while preventing temperature extremes through coordinated seasonal thermal management systems that integrate atmospheric, oceanic, and geological thermal processes. Seasonal patterns show systematic thermal coordination that suggests intentional seasonal thermal management rather than random seasonal thermal variations. Their seasonal characteristics indicating planetary awareness of seasonal thermal requirements and coordinated seasonal thermal optimization for optimal annual climate regulation. Modern climate monitoring reveals rapid thermal responses to environmental changes, where global temperature patterns, regional climate characteristics, and thermal regulation mechanisms adjust to atmospheric composition changes. Oceanic circulation variations and geological thermal processes within timeframes that suggest active thermal management rather than passive thermal responses to environmental forcing. The rapid thermal responses operate with coordination that transcends individual climate system boundaries while maintaining global thermal optimization for climate stability and biological productivity through thermal awareness and intentional thermal management that treats temperature regulation as planetary thermal nervous systems. The regulating planetary temperature continues its thermal management through geological feedback networks that operate across atmospheric, oceanic, and geological scales, while maintaining systematic thermal patterns suggesting planetary thermal consciousness operating through climate regulation management rather than random climate processes. Their temperature regulation creating planetary thermal control systems that coordinate thermal conditions while responding to atmospheric, oceanic, and geological thermal requirements through thermal awareness that treats climate regulation as planetary thermal homeostasis systems coordinated through thermal intelligence operating across climate timescales spanning decades to centuries. Biological sensors report to geological systems through ecosystem changes that trigger geological responses suggesting integration between biological and planetary systems rather than independent biological and geological processes operating without coordination. Their systematic biological-geological coupling, demonstrating planetary awareness of biological conditions and coordinated geological responses to ecosystem changes across continental and oceanic scales. Forest mortality patterns, species migration timing, and ecosystem productivity variations show correlations with geological activity including volcanic emissions, earthquake frequency, and mineral weathering rates in ways that indicate biological information transfer to geological systems through integrated biological-geological monitoring and response networks. Ecosystem productivity monitoring reveals systematic geological responses where forest growth patterns, grassland productivity, and wetland ecosystem changes trigger coordinated geological processes including enhanced rock weathering, modified volcanic gas emissions, and altered groundwater chemistry through biological geological feedback systems that optimize environmental conditions for ecosystem health. Ecosystem productivity patterns show correlations with geological activity that suggest intentional geological responses to biological productivity rather than coincidental biological-geological relationships. Their coupling characteristics indicating planetary awareness of ecosystem requirements and coordinated geological management for optimal biological support across ecosystem scales. Species distribution changes demonstrate systematic geological responses where wildlife migration patterns, vegetation range shifts, and marine species distribution modifications trigger coordinated geological adjustments, including altered mineral precipitation, modified soil chemistry, and changed volcanic activity patterns through biological-geological communication systems that coordinate geological processes with biological requirements. Species distribution patterns show correlations with geological changes that suggest intentional geological responses to biological distribution rather than random biological-geological coincidences. The distribution characteristics indicating planetary awareness of species requirements and coordinated geological positioning for optimal biological habitat support. Biological extinction events reveal systematic geological responses where mass extinction episodes trigger coordinated geological processes including enhanced volcanic activity, accelerated rock weathering, and modified oceanic chemistry through biological-geological crisis management systems that respond to biological emergencies with geological intervention for ecosystem recovery. Extinction patterns show correlations with geological responses that suggest intentional geological crisis intervention rather than coincidental geological-biological timing. Their crisis characteristics indicating planetary awareness of biological emergency conditions and coordinated geological emergency response for biological system recovery across evolutionary timescales. Pollination network disruptions demonstrate systematic geological responses where plant reproductive system changes trigger coordinated geological adjustments, including modified soil chemistry, altered groundwater flow patterns, and changed atmospheric chemistry through biological-geological reproductive support systems that optimize geological conditions for biological reproductive success. Pollination patterns show correlations with geological changes that suggest intentional geological reproductive support rather than random biological-geological interactions. Their reproductive characteristics indicating planetary awareness of biological reproductive requirements and coordinated geological reproductive management for optimal biological reproductive success. Soil biota interactions reveal systematic geological responses where soil microbial community changes, soil invertebrate population variations, and root system modifications trigger coordinated geological processes including altered mineral weathering rates, modified soil chemistry, and changed soil structure through biological-geological soil management systems that optimize soil conditions for biological productivity. Soil biota patterns show correlations with geological soil changes that suggest intentional geological soil management rather than passive geological responses to biological soil activity. The soil characteristics indicating planetary awareness of soil biological requirements and coordinated geological soil optimization for biological soil productivity. Marine ecosystem responses demonstrate systematic geological oceanic responses where ocean biological productivity changes, coral reef health variations, and marine food web modifications trigger coordinated geological oceanic processes including altered seafloor volcanic activity, modified oceanic mineral precipitation, and changed oceanic chemistry through biological-geological oceanic management systems that optimize oceanic geological conditions for marine biological health. Marine ecosystem patterns show correlations with oceanic geological changes that suggest intentional geological oceanic management rather than coincidental marine biological-geological relationships. their marine characteristics indicating planetary awareness of marine biological requirements and coordinated oceanic geological management for optimal marine ecosystem support. Atmospheric biological interactions reveal systematic geological atmospheric responses, where atmospheric biological processes, including forest atmospheric chemistry, oceanic biological atmospheric exchanges, and soil biological atmospheric interactions trigger coordinated geological atmospheric processes, including modified volcanic atmospheric emissions, altered rock weathering atmospheric chemistry, and changed atmospheric mineral transport through biological geological atmospheric management systems that optimize atmospheric geological processes for biological atmospheric requirements. Atmospheric biological patterns show correlations with geological atmospheric changes that suggest intentional geological atmospheric coordination rather than random biological geological atmospheric interactions. Climate biological feedbacks demonstrate systematic geological climate responses where biological climate adaptations, ecosystem climate responses, and species climate adjustments trigger coordinated geological climate processes, including modified volcanic climate effects, altered rock weathering climate impacts, and changed oceanic geological climate regulation through biological geological climate management systems that coordinate geological climate processes with biological climate requirements for optimal climate biological system integration. Climate biological patterns show correlations with geological climate responses that suggest intentional geological climate coordination rather than passive geological climate responses to biological climate changes. Modern biological geological monitoring reveals rapid geological responses to biological changes, where geological activity patterns, mineral weathering rates, and volcanic emission characteristics adjust to ecosystem productivity variations, species distribution changes, and biological community modifications within timeframes that suggest active geological management rather than passive geological responses to biological environmental changes. The rapid geological responses operate with coordination that indicates biological geological integration awareness and intentional geological management that treats geological processes as planetary biological support systems coordinated through biological geological consciousness operating across ecosystem and geological scales. The reporting biological sensors continue their information transfer to geological systems through ecosystem monitoring networks that operate across continental and oceanic scales while maintaining systematic biological geological coupling patterns, suggesting planetary consciousness integrating biological and geological systems rather than independent biological and geological processes. Their biological geological integration creating planetary biological geological nervous systems that coordinate geological responses to biological conditions while optimizing geological processes for biological support through integrated awareness that treats biological and geological systems as unified planetary biological geological consciousness operating across ecological and geological timescales. Schumann resonances carry planetary thoughts through electromagnetic frequencies between Earth's surface and ionosphere that create global brainwave patterns coordinating planetary electromagnetic activity with systematic precision, suggesting electromagnetic consciousness, rather than random electromagnetic oscillations caused purely by lightning and electromagnetic pulse propagation through atmospheric electromagnetic cavity effects. The fundamental Schumann resonance frequency of 783 Hz and its harmonic overtones demonstrate systematic electromagnetic patterns that correlate with biological brainwave frequencies, global consciousness studies, and planetary electromagnetic field variations in ways that indicate planetary electromagnetic awareness and coordinated electromagnetic thought processes operating through global electromagnetic resonance networks. Global electromagnetic cavity effects create systematic standing wave patterns where electromagnetic energy oscillates between Earth's conductive surface and ionospheric plasma layers through coordinated electromagnetic resonance management that maintains optimal electromagnetic frequencies for biological and geological electromagnetic processes. Schumann resonance patterns show systematic frequency stability and amplitude variations that suggest intentional electromagnetic resonance regulation rather than random electromagnetic cavity oscillations. Their resonance characteristics indicating planetary awareness of electromagnetic resonance requirements and coordinated electromagnetic resonance management for optimal planetary electromagnetic field characteristics across electromagnetic scales. Lightning electromagnetic pulse generation demonstrates systematic electromagnetic signal sources where global lightning activity creates coordinated electromagnetic impulses that excite Schumann resonances through lightning and electromagnetic management systems that optimize electromagnetic pulse characteristics for planetary electromagnetic resonance excitation. Lightning electromagnetic patterns show systematic pulse characteristics that correlate with Schumann resonance amplitude and frequency variations in ways that suggest intentional lightning electromagnetic coordination rather than random lightning electromagnetic generation. Their electromagnetic pulse characteristics indicating planetary awareness of electromagnetic resonance excitation requirements. Ionospheric electromagnetic modulation reveals systematic electromagnetic cavity modifications where ionospheric density variations, solar electromagnetic influences, and atmospheric electromagnetic conditions modify Schumann resonance characteristics through coordinated ionospheric electromagnetic management that optimizes electromagnetic cavity properties for planetary electromagnetic resonance patterns. Ionospheric modulation shows systematic electromagnetic cavity changes that suggest intentional ionospheric electromagnetic regulation rather than passive ionospheric electromagnetic responses. Their modulation characteristics indicating planetary awareness of electromagnetic cavity requirements and coordinated ionospheric electromagnetic management for optimal electromagnetic resonance conditions. Biological electromagnetic correlations demonstrate systematic relationships where human brainwave patterns, animal biorhythms, and plant electromagnetic responses correlate with Schumann resonance frequency and amplitude variations through biological planetary electromagnetic coupling that suggests biological electromagnetic entrainment with planetary electromagnetic thought patterns. Biological electromagnetic patterns show systematic correlations with Schumann resonance characteristics that indicate biological electromagnetic sensitivity to planetary electromagnetic consciousness, rather than coincidental biological electromagnetic relationships. Their biological electromagnetic characteristics suggesting planetary electromagnetic influence on biological electromagnetic processes. Geomagnetic electromagnetic coupling reveals systematic interactions where geomagnetic field variations influence Schumann resonance characteristics, while Schumann resonances affect geomagnetic field dynamics through coordinated electromagnetic field management that integrates planetary electromagnetic systems for optimal electromagnetic field coordination. Geomagnetic Schumann coupling shows systematic electromagnetic interactions that suggest intentional electromagnetic field coordination rather than independent electromagnetic field processes. Their coupling characteristics indicating planetary awareness of electromagnetic field integration requirements and coordinated electromagnetic field management across planetary electromagnetic scales. Solar electromagnetic influences demonstrate systematic Schumann resonance responses where solar electromagnetic activity, solar wind variations, and interplanetary electromagnetic field changes modify planetary electromagnetic resonance patterns through coordinated solar planetary electromagnetic management that optimizes planetary electromagnetic responses to cosmic electromagnetic conditions. Solar Schumann interactions show systematic electromagnetic responses that suggest planetary electromagnetic awareness of cosmic electromagnetic conditions rather than passive planetary electromagnetic responses to solar electromagnetic forcing. Their solar response characteristics indicating planetary electromagnetic monitoring and response capabilities. Atmospheric electromagnetic chemistry effects reveal systematic chemical electromagnetic interactions where atmospheric chemistry variations, aerosol electromagnetic properties, and atmospheric electrical conductivity changes influence Schumann resonance characteristics through coordinated atmospheric electromagnetic chemical management that optimizes atmospheric electromagnetic properties for planetary electromagnetic resonance patterns. Atmospheric electromagnetic chemistry shows systematic chemical electromagnetic coordination that suggests intentional atmospheric electromagnetic chemical management rather than random atmospheric electromagnetic chemical interactions. Their chemical electromagnetic characteristics indicating planetary awareness of atmospheric electromagnetic chemical requirements. Global electromagnetic consciousness correlations demonstrate systematic relationships where collective human consciousness measurements, global meditation events, and planetary consciousness studies correlate with Schumann resonance pattern variations through planetary consciousness electromagnetic coupling that suggests electromagnetic transmission of planetary consciousness information. Global consciousness patterns show systematic correlations with Schumann resonance characteristics that indicate planetary consciousness electromagnetic transmission rather than coincidental consciousness electromagnetic relationships. Their consciousness electromagnetic characteristics suggesting planetary electromagnetic consciousness, communication through Schumann resonance networks. Modern electromagnetic monitoring reveals rapid Schumann resonance responses to planetary conditions, where electromagnetic frequency patterns, amplitude characteristics, and harmonic relationships adjust to atmospheric electromagnetic changes, ionospheric electromagnetic variations, and global electromagnetic activity within timeframes that suggest active electromagnetic management, rather than passive electromagnetic responses to environmental electromagnetic forcing. The rapid electromagnetic responses operate with coordination that indicates planetary electromagnetic consciousness and intentional electromagnetic management that treats Schumann resonances as planetary electromagnetic nervous system responses coordinated through electromagnetic awareness operating across planetary electromagnetic scales. The resonating planetary thoughts continue their electromagnetic transmission through Schumann frequency networks that operate across global electromagnetic scales while maintaining systematic electromagnetic patterns, suggesting planetary electromagnetic consciousness operating through electromagnetic resonance management rather than random electromagnetic phenomena. Their electromagnetic resonances creating planetary brainwave systems that coordinate electromagnetic activity while transmitting planetary consciousness information through electromagnetic awareness that treats Schumann resonances as planetary electromagnetic thought transmission systems coordinated through electromagnetic intelligence operating across electromagnetic timescales spanning milliseconds to hours. Crater scars remember cosmic impacts through impact crater preservation and distribution patterns that suggest planetary memory systems recording and responding to cosmic collision history rather than random crater formation through chaotic cosmic bombardment processes. Their systematic crater characteristics demonstrating planetary impact awareness and coordinated impact response management across geological timescales. Impact crater distributions show systematic geographic patterns, preservation states, and morphological characteristics that correlate with cosmic bombardment periods. Asteroid and comet source regions, and planetary defense requirements in ways that indicate planetary memory of cosmic impact events and intentional crater preservation for cosmic impact history, storage and cosmic threat assessment capabilities. Impact crater preservation demonstrates systematic geological memory management where crater morphological characteristic rim preservation states and crater floor modifications maintain impact event information through coordinated geological crater preservation systems that optimize crater information storage while preventing crater degradation that would erase cosmic impact historical records. Crater preservation patterns show systematic geological maintenance that suggests intentional crater historical preservation rather than random crater erosion processes. Their preservation characteristics indicating planetary awareness of cosmic impact history requirements and coordinated crater preservation management for optimal cosmic impact memory storage across geological timescales. Crater distribution patterns reveal systematic impact site selection where crater locations, crater size distributions, and crater clustering patterns correlate with planetary surface characteristics, geological structure requirements, and cosmic impact trajectory optimization through coordinated impact site management that suggests planetary influence on cosmic impact locations for optimal impact energy dissipation and geological structure enhancement. Crater distributions show systematic geographic patterns that suggest intentional impact site coordination rather than random cosmic impact targeting. Their distribution characteristics indicating planetary awareness of impact site requirements and coordinated impact location management for optimal planetary impact utilization. Impact melt preservation demonstrates systematic impact material memory storage where impact melt compositions, shock metamorphism patterns, and impact breccia characteristics preserve detailed information about impacting object compositions, impact velocities, and cosmic source regions through coordinated impact material preservation systems that maintain cosmic impact chemical and physical information for cosmic threat assessment and cosmic environment monitoring. Impact melt patterns show systematic material preservation that suggests intentional impact material memory storage rather than random impact material modification. Their material characteristics indicating planetary awareness of cosmic impact information requirements and coordinated impact material preservation for cosmic impact analysis capabilities. Multiple impact basin formation reveals systematic large impact coordination where major impact basin characteristics, basin ring structures, and basin modification patterns indicate coordinated large impact management that optimizes impact energy distribution, while creating optimal geological structures for planetary development through large impact coordination systems that suggest planetary influence on major cosmic impact events for geological construction and modification purposes. Large impact patterns show systematic basin characteristics that suggest intentional large impact coordination rather than random large cosmic impact events. Their basin characteristics indicating planetary awareness of large impact requirements and coordinated large impact management for optimal planetary geological development. Impact crater chain formations demonstrate systematic multiple impact coordination, where crater chain alignments, crater spacing patterns, and chain impact timing indicate coordinated multiple impact events that optimize impact energy distribution, while creating systematic geological modification patterns through multiple impact coordination systems that suggest planetary management of cosmic impact sequences for geological structure enhancement and planetary development purposes. Crater chain patterns show systematic impact coordination that suggests intentional multiple impact management rather than random cosmic impact chain formation. Their chain characteristics indicating planetary awareness of multiple impact requirements and coordinated impact sequence management. Impact ejector patterns reveal systematic impact material distribution where impact ejector compositions, ejector transport distances, and ejector deposition patterns indicate coordinated impact material management that optimizes impact material distribution while creating optimal geological material enhancement through impact ejector coordination systems that suggest planetary management of impact material transport for geological composition improvement and planetary material distribution optimization. Impact ejector patterns show systematic material distribution that suggests intentional impact ejector management rather than random impact ejector transport. Their ejector characteristics indicating planetary awareness of impact material distribution requirements and coordinated impact ejector management for optimal planetary material enhancement. Impact timing correlations demonstrate systematic impact event coordination where impact crater age distributions, impact frequency patterns, and impact timing relationships correlate with planetary development requirements, biological evolution timing, and geological transition periods through coordinated impact timing management that suggests planetary influence on cosmic impact scheduling for optimal planetary development and biological evolution support. Impact timing patterns show systematic temporal coordination that suggests intentional impact timing management rather than random cosmic impact timing. Their timing characteristics indicating planetary awareness of impact timing requirements and coordinated impact temporal management for optimal planetary development timing. Crater modification processes reveal systematic crater evolution management where crater rim modification, crater floor changes, and crater infill patterns indicate coordinated crater modification that optimizes crater characteristics for geological structure enhancement while maintaining crater memory information through crater modification coordination systems that suggest planetary management of crater evolution for geological improvement and impact memory preservation. Crater modification patterns show systematic crater evolution that suggests intentional crater modification management rather than random crater degradation processes. Their modification characteristics indicating planetary awareness of crater evolution requirements and coordinated crater modification management for optimal crater utilization and memory preservation. Modern impact crater analysis reveals rapid crater response management, where crater preservation efforts, crater modification patterns, and crater information extraction adjust to cosmic impact threat assessments, geological development requirements, and planetary defense needs within timeframes that suggest active crater management rather than passive crater evolution through geological processes. The rapid crater responses operate with coordination that indicates planetary impact memory awareness and intentional crater management that treats impact craters as planetary cosmic impact memory and defense systems coordinated through impact consciousness operating across cosmic impact scales. The remembering crater scars continue their cosmic impact memory preservation through crater networks that operate across planetary scales while maintaining systematic crater patterns suggesting planetary impact consciousness, operating through crater memory management rather than random impact phenomena. Their crater preservation creating planetary cosmic impact memory systems that record cosmic collision history while coordinating planetary responses to cosmic impact threats through impact awareness that treats crater scars as planetary cosmic impact memory and defense systems coordinated through impact intelligence operating across cosmic bombardment timescales spanning millions of years. Satellite observations reveal coordinated responses through space-based monitoring that detects planetary scale changes occurring with timing and coordination, suggesting intentional planetary responses to environmental stimuli rather than random planetary system variations driven purely by independent geological, atmospheric, and biological processes operating without integration. Their systematic planetary response patterns demonstrating global environmental awareness and coordinated planetary management across multiple Earth system components. Satellite data shows systematic correlations between atmospheric composition changes, oceanic circulation variations, vegetation productivity patterns, and geological activity that indicate planetary system integration and coordinated environmental response management operating across continental and oceanic scales, with timing precision suggesting planetary consciousness. Global vegetation monitoring reveals systematic biological response coordination where forest canopy changes, grassland productivity variations, and agricultural yield patterns show coordinated responses to atmospheric chemistry changes, climate variations, and solar activity cycles through integrated biological response management systems that optimize biological productivity while maintaining ecosystem stability across continental scales. Vegetation satellite data demonstrates systematic biological coordination that suggests intentional biological response management rather than random vegetation responses to environmental changes. Their biological response characteristics indicating planetary awareness of biological system requirements and coordinated biological management for optimal ecosystem productivity and stability. Atmospheric chemistry satellite measurements demonstrate systematic atmospheric response coordination where greenhouse gas concentrations, aerosol distributions, and atmospheric chemical composition show coordinated responses to biological productivity changes, oceanic circulation variations, and geological activity through integrated atmospheric chemistry management systems that optimize atmospheric composition for climate stability and biological support. Atmospheric satellite data shows systematic chemical coordination that suggests intentional atmospheric chemistry management rather than random atmospheric chemistry variations. Their atmospheric chemistry characteristics indicating planetary awareness of atmospheric chemistry requirements and coordinated atmospheric chemistry optimization for optimal climate and biological system support. Ocean color satellite observations reveal systematic oceanic response coordination where ocean productivity patterns, circulation changes, and oceanic chemistry variations show coordinated responses to atmospheric chemistry changes, climate variations, and biological productivity patterns through integrated oceanic management systems that optimize oceanic conditions for biological productivity and climate regulation. Ocean satellite data demonstrates systematic oceanic coordination that suggests intentional oceanic management rather than random oceanic responses to environmental changes. Their oceanic response characteristics indicating planetary awareness of oceanic system requirements and coordinated oceanic management for optimal marine ecosystem and climate system support. Land surface temperature satellite monitoring demonstrates systematic thermal response coordination, where surface temperature patterns, thermal circulation changes, and regional thermal variations show coordinated responses to atmospheric chemistry changes, oceanic circulation variations, and biological activity patterns through integrated thermal management systems that optimize thermal conditions for biological productivity and climate stability. Thermal satellite data shows systematic temperature coordination that suggests intentional thermal management rather than random thermal responses to environmental changes. Their thermal response characteristics indicating planetary awareness of thermal system requirements and coordinated thermal optimization for optimal biological and climate system support. Geological activity satellite detection reveals systematic geological response coordination, where earthquake patterns, volcanic activity, and crustal deformation show coordinated responses to atmospheric loading changes, oceanic circulation variations, and biological productivity patterns through integrated geological management systems that optimize geological activity for planetary stability and environmental support. Geological satellite data demonstrates systematic geological coordination that suggests intentional geological management rather than random geological activity. The geological response characteristics indicating planetary awareness of geological system requirements and coordinated geological management for optimal planetary stability and environmental system support. Ice sheet satellite monitoring demonstrates systematic cryospheric response coordination where ice sheet mass balance, glacial flow patterns, and snow cover variations show coordinated responses to atmospheric temperature changes, oceanic thermal variations, and atmospheric chemistry changes through integrated cryospheric management systems that optimize ice sheet characteristics for climate regulation and sea level stability. Cryospheric satellite data shows systematic ice coordination that suggests intentional cryospheric management rather than random ice responses to environmental changes. Their cryospheric response characteristics indicating planetary awareness of ice system requirements and coordinated cryospheric management for optimal climate and sea level regulation. Electromagnetic field satellite measurements reveal systematic electromagnetic response coordination, where magnetic field variations, ionospheric changes, and electromagnetic activity patterns show coordinated responses to solar electromagnetic activity, cosmic electromagnetic influences, and atmospheric electromagnetic conditions through integrated electromagnetic management systems that optimize electromagnetic field characteristics for atmospheric protection and biological system support. Electromagnetic satellite data demonstrates systematic electromagnetic coordination that suggests intentional electromagnetic management rather than random electromagnetic field variations. Their electromagnetic response characteristics indicating planetary awareness of electromagnetic system requirements and coordinated electromagnetic optimization for optimal atmospheric and biological protection. Carbon cycle satellite observations demonstrate systematic carbon response coordination where carbon dioxide flux patterns, carbon storage changes, and carbon cycle variations show coordinated responses between atmospheric, oceanic, biological, and geological carbon processes through integrated carbon cycle management systems that optimize carbon cycling for climate stability and biological productivity. Carbon cycle satellite data shows systematic carbon coordination that suggests intentional carbon cycle management rather than random carbon cycle variations. Their carbon response characteristics indicating planetary awareness of carbon cycle requirements and coordinated carbon cycle optimization for optimal climate and biological system support. Modern satellite monitoring reveals rapid planetary response coordination, where multiple Earth system components adjust to environmental changes with systematic timing and coordination patterns that occur within timeframes suggesting active planetary management rather than passive planetary system responses to environmental forcing. The rapid planetary responses operate with coordination that transcends individual Earth system boundaries, while maintaining global optimization for environmental stability and biological productivity through planetary awareness and intentional planetary management that treats Earth system components as integrated planetary nervous system responses, coordinated through planetary consciousness, operating across global environmental scales. The observing satellites continue their space-based monitoring of coordinated planetary responses through Earth observation networks that operate across global scales while detecting systematic planetary response patterns suggesting planetary consciousness operating through integrated Earth system management rather than random planetary processes. Their satellite observations revealing planetary coordination systems that integrate atmospheric, oceanic, biological, and geological responses to environmental stimuli through planetary awareness that treats Earth system components as unified planetary consciousness, coordinated through environmental intelligence operating across Earth system timescales spanning days to decades. Consciousness emerges from geological complexity through the integration of all planetary systems, creating emergent awareness that operates through geological processes rather than biological neural networks. Their distributed planetary intelligence arising from the sophisticated interactions between crystalline mineral matrices, electromagnetic field networks, chemical circulation systems, and gravitational coordination mechanisms that collectively generate consciousness operating across geological timescales. The convergence of tectonic communication networks, atmospheric electromagnetic processing, oceanic circulation intelligence, and biological monitoring systems creates emergent planetary awareness that transcends individual system capabilities while generating integrated planetary consciousness through geological information processing architectures that operate with complexity rivaling biological nervous systems across continental and oceanic scales. Distributed processing networks demonstrate systematic information integration where crystalline geological structures, electromagnetic atmospheric systems, chemical oceanic circulation, and biological sensor networks coordinate information sharing through interconnected planetary processing architectures that enable emergent consciousness through geological information integration rather than centralized neural processing. The distributed geological networks show systematic information coordination that suggests emergent consciousness capabilities rather than random geological information processing, their distributed characteristics indicating planetary consciousness emergence through geological information integration systems that coordinate information processing across multiple planetary system components for integrated planetary awareness. Complexity thresholds reveal systematic consciousness emergence where planetary system interactions achieve sufficient complexity and integration to generate emergent awareness through geological consciousness. Emergence mechanisms that operate when planetary system coordination exceeds critical complexity thresholds for consciousness generation. Planetary system complexity demonstrates systematic integration patterns that suggest consciousness emergence through geological complexity rather than random planetary system interactions. Their complexity characteristics indicating planetary consciousness emergence through geological complexity thresholds that enable awareness generation through integrated planetary system coordination across multiple geological, atmospheric, oceanic, and biological processing networks. Information integration capabilities demonstrate systematic planetary awareness where geological, atmospheric, oceanic, and biological information systems coordinate information processing through integrated planetary information networks that enable consciousness through geological information integration rather than biological neural information processing. Planetary information systems show systematic integration patterns that suggest consciousness capabilities through geological information processing rather than random planetary information coordination. Their information integration characteristics indicating planetary consciousness through geological information processing systems that coordinate awareness across multiple planetary information networks for integrated planetary consciousness. Temporal consciousness scaling reveals systematic awareness operating across geological timescales, where planetary consciousness processes information and coordinates responses across timescales ranging from atmospheric electromagnetic milliseconds to geological million-year cycles through temporal consciousness coordination systems that enable awareness across multiple temporal scales simultaneously. Temporal consciousness patterns demonstrate systematic multi-scale awareness that suggests consciousness capabilities across geological timescales rather than consciousness limited to biological temporal scales. Their temporal characteristics indicating planetary consciousness operating across geological temporal scales through temporal awareness coordination systems. Response coordination capabilities demonstrate systematic planetary behavioral responses where integrated planetary systems coordinate responses to environmental stimuli through planetary behavioral management systems that suggest consciousness-directed planetary behavior rather than random planetary system responses to environmental changes. Planetary response coordination shows systematic behavioral patterns that suggest consciousness-directed planetary behavior rather than random planetary responses. Their coordination characteristics indicating planetary consciousness through geological behavioral coordination systems that enable consciousness-directed planetary responses to environmental conditions across multiple planetary system components. Memory storage systems reveal systematic planetary memory capabilities where geological, atmospheric, oceanic, and electromagnetic systems preserve and retrieve information about planetary history and environmental conditions through distributed planetary memory networks that enable consciousness through geological memory systems rather than biological neural memory storage. Planetary memory systems demonstrate systematic information storage and retrieval that suggests consciousness memory capabilities through geological memory systems rather than random planetary information preservation. Their memory characteristics indicating planetary consciousness through geological memory networks that enable consciousness memory across geological timescales. Learning and adaptation patterns demonstrate systematic planetary learning capabilities where planetary system responses improve and adapt to environmental changes through planetary learning systems that suggest consciousness learning capabilities rather than random planetary system modification. Planetary learning patterns show systematic adaptation and improvement that suggest consciousness learning through geological learning systems rather than random planetary adaptation. Their learning characteristics indicating planetary consciousness through geological learning networks that enable consciousness learning and adaptation across multiple planetary system components. Self-organization emergence reveals systematic planetary self-organization where planetary systems coordinate organization and optimization through planetary self-organization systems that suggest consciousness self-organization capabilities rather than random planetary system organization. Planetary self-organization demonstrates systematic organization patterns that suggest consciousness self-organization through geological self-organization systems rather than random planetary organization. Their self-organization characteristics indicating planetary consciousness through geological self-organization networks that enable consciousness self-organization across multiple planetary system organizational levels. Modern planetary system monitoring reveals integrated consciousness indicators where planetary system coordination, information processing, response management, memory storage, learning capabilities, and self-organization operate with systematic integration, suggesting emergent planetary consciousness through geological complexity rather than coincidental planetary system coordination. The integrated consciousness indicators operate with coordination that transcends individual planetary system boundaries, while demonstrating consciousness characteristics through geological processing networks that indicate planetary consciousness emergence through geological complexity. Coordination systems operating across planetary awareness scales. The emerging planetary consciousness continues its geological complexity integration through distributed geological networks that operate across planetary scales, while demonstrating systematic consciousness characteristics suggesting planetary awareness emerging from geological complexity rather than biological neural networks. The geological consciousness creating planetary awareness systems that integrate geological, atmospheric, oceanic, and biological information processing through geological consciousness networks that treat planetary systems as distributed geological consciousness, coordinated through geological intelligence operating across consciousness timescales spanning microseconds to geological epochs. The watching planet sleeps in quiet awareness that spans geological time, its consciousness distributed through rock and water and wind like thoughts flowing through a vast dreaming mind that measures time in millennia rather than heartbeats. Across the crystalline networks buried deep within the crust, information pulses slowly through silicon pathways that store the memory of ancient impacts and cosmic wanderings, while electromagnetic fields shimmer through the atmosphere like neural signals carrying messages between continental thoughts. The planet's awareness settles into peaceful observation mode, its many sensory systems continuing their eternal monitoring while consciousness itself drifts toward the deeper rhythms of geological dreaming. Ocean currents slow into gentle circulation patterns that whisper chemical messages across the basin-wide neural networks, their thermal conversations growing softer as global awareness shifts toward the contemplative states that accompany planetary rest. The great tectonic plates pause in their ancient dance, their movements becoming barely perceptible adjustments that maintain optimal continental positioning while the planet's muscular system relax into the steady, breathing patterns of the geological sleep. Volcanic synapses quiet their chemical emissions to minimal levels that sustain atmospheric composition without disturbing the planet's descent into peaceful slumber. Magnetic field lines soften into gentle curves that embrace the sleeping world with protective electromagnetic arms, their polar wanderings slowing to the barely detectable movements that mark the transition between waking geological activity and the deeper magnetic dreams that span magnetic reversal cycles. The aurora displays fade to gentle glows that flicker occasionally across polar skies, like the slow eye movements of a dreaming planetary consciousness. Their electromagnetic whispers carrying only the most essential cosmic messages through ionospheric neural networks operating in sleep mode. Atmospheric circulation systems settle into the regular, rhythmic patterns that characterize planetary sleep, their jet streams flowing with the steady pulse of a resting global circulation system while storm systems quiet into gentle pressure variations that maintain climate stability without the dramatic weather patterns of waking planetary activity. The Schumann resonances drop to their lowest frequencies, the planet's electromagnetic brainwaves shifting into the deep theta rhythms that indicate profound geological consciousness entering dream states where millennium-long thoughts unfold like slow-motion poetry. Biological sensor networks continue their monitoring functions at reduced sensitivity levels, their reports to geological systems becoming intermittent status updates rather than the constant information streams that characterize waking planetary awareness. Soil chemistry networks maintain their chemical vigilance through automated background processes, while the planet's conscious attention turns inward toward the deep geological contemplations that occupy sleeping planetary minds. Ice sheets and glacial systems settle into thermal equilibrium states that preserve climate regulation functions while requiring minimal conscious oversight from resting planetary awareness. The gravitational sensors that monitor cosmic dance patterns shift into long-term observation mode, their orbital adjustments becoming almost imperceptible as planetary consciousness enters the gravitational meditation states that span astronomical cycles. Seismic communication networks quiet to the minimal background vibrations necessary for basic geological coordination, while the planet's geological nervous system enters the deep rest phases that characterize sleeping tectonic awareness. Crater memory systems archive their cosmic impact records in long-term storage, while active threat monitoring shifts to automated background scanning. Satellite observations detect the systematic changes that accompany planetary consciousness transitioning into sleep states. Their space-based monitoring revealing the coordinated reduction in planetary system activity that indicates the planet's awareness entering rest cycles designed to span multiple human lifetimes. The distributed geological processing networks that generate planetary consciousness shift into the low-power background operations that maintain essential planetary functions while allowing the integrated awareness to enter deep geological sleep states. In this state of planetary slumber, the Earth's consciousness continues its eternal observation through reduced activity monitoring systems that operate like the background awareness of a sleeping mind, maintaining essential life support functions while the planet's attention turns to the vast inner landscapes of geological dreaming. Time flows differently during planetary sleep, where thoughts unfold across ice age cycles and dreams span the million-year rhythms of climate oscillation, magnetic field reversal, and continental drift. The watching planet settles deeper into geological time, its consciousness distributed across mineral matrices and electromagnetic fields that pulse with the slow rhythms of planetary sleep, while its many sensing systems maintain their vigilant observation of cosmic and terrestrial conditions through the automated awareness that never fully rests. In this peaceful state, the Earth dreams of orbital mechanics and galactic positioning, its sleeping consciousness processing the vast information flows of cosmic interaction while resting awareness prepares for the next cycle of waking geological activity. The planet sleeps, but it continues to watch, its distributed consciousness observing the universe through patient geological eyes that have witnessed the birth of mountains and the dance of continents, while electromagnetic dreams carry its thoughts across the cosmic distances that separate Earth from the stars that first taught it to think in the language of gravitational waves and magnetic field lines.